Well, hey everybody, welcome to another exam prep night. My name's Paul Abernathy, if you don't know who I am. We didn't do it last week. We're doing it this week. We're going to look at some exam prep, answer some questions you might have. So again, send it out on our Facebook page and over on our Twitter feeds, and of course on our LinkedIn, a bunch of different platforms that we announce that we're doing this. And again, you should know that we typically do this every Wednesday evening at about 7 p.m. Sometimes it can be 7:30, but I usually send out notifications. So if you're studying for an exam and you're not a member of our Facebook platform, then you need to jump on over to our Facebook platform and sign up for it. It's free. You have to answer a couple questions, and then you can get into the program. And again, it allows you to post your questions, and other members can chime in, and everything looks good. Well, it'll keep flowing. If something looks like it's going the wrong direction and it's not accurate information, then I'll step in. And but usually I stay pretty much hands off, unless I need to get in and do some direction or something like that. Or if you have a question and I see that it's not getting answered, then I'll try to step in. One thing about posting questions over in our Facebook, which is actually called Master the NEC Exam Prep. So there's two different forums over there. One of them is for the exam prep, and then of course the other one is for just posting anything you want to post. Any question, anything that you care to post, you can post there. Code, ask this or that or whatnot, so you can do that as well. But if you have something that pertains to exam prep, then you want to be over in the Master the NEC Exam Prep forum. That's just the best one to be if you want to ask those type of exam-related type of questions. I typically don't like questions that are not exam prep related in that forum. You can post that over in our Master the NEC forum. Of course, there's my dog. Over in our Master the NEC forum, which is basically just an open forum for you to post your questions. Okay, but if it's exam related, definitely make sure that you sign up for a Master the NEC Exam Prep forum. Okay, most certainly want to make sure that you sign up for that. All right, so again, I'm not seeing any chats on here or anything, or nobody's saying anything, so I don't know if the feature's working or not. It seems like it's working because I post some information in there. So somebody will post something to let me know that the chat's working. It would be, it'd be great. That way I know that something's functioning when it comes to the chats. Okay, Carlos, Xavier. Okay, good deal. All right, at least I know it's working. So everybody else is just really, really silent. That's not going to work for exam prep, okay? You can't be silent, okay? You have to be very active, and you have to ask your questions in order to, what's that old saying? You got to ask and you shall receive. So you have to make sure that you ask your questions, and we'll look at some exams. So hopefully you've got your code books with you or access to them. When we start posting some exam questions and I give you some ideas on these questions on how to look them up and how to dissect certain things of it. A couple weeks ago, we went through our Fast Tracks program, actually through the competency reviews, and I got a bunch of emails from students who said they didn't like that because they hadn't got to that unit yet. Of course, I told you don't watch if you're not at that unit yet, but it actually gave away information that they wanted to read and learn, and that's how you retain it. So very rarely will I do that, whereas I'm going to go into the competency reviews because the Fast Tracks program is very much based on those competency reviews, very based on the competency reviews. So we're going to look at exam questions, things like that. But again, for the full scope, you really got to be a member of the Fast Tracks to get an understanding of the competency review questions and how they are designed. And they're designed based on the material that you're supposedly reading during the course of you working through each unit. Okay, so let me catch up real quick for those that are here. And again, sporting the scruffiness this week. This is my COVID-19. I just started a couple weeks to 2 weeks ago or so. And, you know, it was a challenge that was presented to me by another educator. So I can't grow a beard. So this is it. All right. So anyway, so I want to say Carlos, Xavier, Tim, James, Josh. Just talked to Josh on the phone a few minutes ago. Thank you, Josh. Ross. Okay. Thank you for joining. We do this each week. And again, for those that aren't familiar with what we're getting into here, we all of the nights is based on the Fast Tracks program and what it has. And a lot of the questions that we'll look at tonight in the Fast Tracks program, you might be surprised to see some of these pop up on exams. Okay. So kind of really good questions, kind of questions that make you think. Couple tips that I'll tell you up front. Okay. Hey, Terrell, thanks for coming. Hey, Tommy. No problem, brother. Enjoy coming here and hopefully giving you some lessons and helps you out in any way possible. I'm also getting an awful lot of emails from people that are passing their exams. So that's exciting too. I always get really excited when I get these little emails from students that are in the program or watch my videos or the podcasts, and they get really excited. Now, I have to admit, I've been lax on some videos lately. Been a lot of things going on here at the Academy. So I got to get back into that. For those that are in the paid subscription over on this YouTube channel, the paid one, you've got 2 more episodes of Article 680 that are exclusive to members only, the ones that pay the monthly subscription, which is as little as $4.99. But the information you get is huge, I think. Anyway, I'm biased, of course. But we've got 2 more episodes of Article 680, and then we'll get back to the 2020 analysis. And we're up to Article 215. We've covered all of 210, 100, 110, definitions, covered all that. So we're going to get back into that series. And again, that's exclusive only for members that are part of the membership on our YouTube channel. And that's different than being a subscriber. This is the join membership feature. And you see a little join button. You got 3 options to do it. The best option is the exclusive member or VIP member, the highest level. Then that means you get 10% off of any of our stuff at Electrician Pride. If you don't need that stuff, then don't do it. You don't have to do that. You can go with the lowest one. You'll still get everything you need. Okay? So again, let's see. Anybody else come in? No, we're good. All right. Okay. Now, let me give you some tips about exam prep, because I got an awful lot of students and a lot of people emailing me that they struggle on tests. And first things first, let me talk about this if you're in the Fast Tracks program first. You need to do unit after unit after unit. You can't skip around. It's not going to do you any good to go from unit 4 and then jump up to unit 12. The hardest units you're going to encounter in this program are 7, 8, 9, 10, 11, and 12. Those are the hardest units, okay, that you're going to have. And so, again, you can't skip around and expect to be successful in it. There's just too many things, and those are really focused on calculations. So it really doesn't do you any good to skip around. So that's a tip for Fast Tracks people. Don't skip around. Do everything. When you go to Unit 1, do everything in that module. Go to Unit 2, do everything in that module. Okay? Do not jump around. It's not going to do you any good. Also, tip for those that are in the program, and I'll get to you that are not. I'll get tips for you before we get started tonight and deeper. Every week that you're in the Fast Tracks program, you should be dropping down and doing one of the practice exams. If your scores are coming back in the 60s and the low 70s, then you need more work. And so that's okay. You can do the test multiple times. That's the beautiful thing about the Fast Tracks program. You can take those online. They replicate like an exam. Take them as many times as you want to get those scores up. Repetition is good. But remember, you should be doing at least one of those a week. While you're doing your units, then you should be doing an exam at the bottom, then you should be doing a unit and work your way that way. So that's kind of the concept Hopefully I've conveyed that many times over the last couple of years that we've had the program, that you've really got to be involved in it. Those practice exams are there. You paid for them. You need to utilize them, and they're really good. I've noticed that Mr. Pfister is taking an exam tomorrow. So we're going to, say that, and we're going to give you a big prayer that everything goes good. If you're ready, you feel confident, no sense in cramming late tonight. Get a good night's sleep if you got to do it at 9 a.m. If you don't know it by now, you can do some tonight because we're having fun. But if you don't know it by now, don't try to think you're going to absorb it all tonight, because then you get confused, right? You'll get confused and you'll see something and you don't get it right away, and you'll get flustered. You should not go into an exam flustered. Okay? This is not going to be beneficial to you. All right? Like Kevin says, hey, Kevin, welcome to the stream. You have to put in the work. Okay? I always tell people this. Look, I have plenty of people that come to me that pass their exams that don't use my courses, but they use my videos and they use my podcasts. And I love it. I have no problem with it at all. If you need a structured plan, that's what Fast Tracks is all about. If you feel you can do it on your own, you just need to study with a purpose. And in doing so, you need a good set of exam questions, and you need to dissect the questions. That's why I spend a lot of time on that. Now, calculations, we don't spend a whole lot of time here on calculations, except for some of the ones that are probably going to be on exams, one easy 1, 2, or 3 step stuff. But the program, the Fast Tracks program, gets really deep into in-depth calculations. And we got the forms that you should be printing out and using every time you do a competency review, especially in units 7, 8, 9, 10. You should be printing those out and using them. And you can make multiple copies of it. But what I find is that most people fail an exam, and they fail by 1 question or 2 questions, and they think, I only failed by 1 and 2. But reality is you fail by a lot more than that. Okay? If you just pass, you still had a whole bunch of questions you got wrong, obviously. And again, I'm all about training you to understand it long term, being able to retain it. I want to be a resource here for you to bounce questions off of me. You can email me, call me anytime. I think Josh called me tonight multiple times. He had no problem getting in touch with me. I'm available to reach me, email me, whatever's necessary. Okay? So, again, I want to be a resource. I want you to succeed. That's the goal. I want you to succeed. Not every program is perfect. Okay? But the tools are there in the Fast Tracks program for those that are in it. If you're not in the Fast Tracks program, it's okay. You just need to study with a purpose. It's not going to do you any good to just grab a code book and start flipping. You have to be going in there for a reason. Okay? Now, you can make up plenty of examples if you want and test your knowledge. Just say whether it's ranges or dryers. You know what the values are. Set yourself up and ask you what the calculated load is for 5 ranges and work it. You know what I mean? Pretty simple to do. Or for calculations, go watch my videos. I got one on ranges, got one on dryers, I got one on multifamily dwellings, got one on single family, optional and standard method. It walks you through each piece. All of that's available over on our channel. So I don't do that here because majority of the time people have a problem understanding code questions, have a hard time understanding how to look them up, how to dissect them, right? And so that's what we try to focus on here because of the limited time. If you have a specific calculation, I want to tell you, I'm here to help you. Email it to me, info at masterthenec.com, and I will work that calculation and show you how to work it. My job is for you to be successful, okay? And trust me, it's not all about us selling courses, okay? Because people know that I have a full-time job as a head of codes and standards for a large manufacturer, okay? I have the luxury to be able to keep my courses low, not $1,200, keep it low, and I still answer your emails. I still do the competency reviews. I put in the time to be there for you, but you got to put in the time, Okay, you have to put in the time. This is your license, right? Okay, so, all right, what do we got? Elwood's in the house. How you doing in there? So again, yes, definitely, Mr. Pfister, good luck tomorrow. Hopefully, if you pass it, you'll still be coming back here to learn more, because there's always more to learn. And if you be honest with you, nobody else started doing the internet stuff until I did it. I've been doing it since 2004. COVID-19 hit, then other educators decided they wanted to go online and do some teaching. Yeah, I've been doing this for well over a decade. Okay, so let's just say. So again, trying to bring the education, and again, it's not all about courses. It's about you learning, and I want to be a resource. I have guys that call me all the time, and ask me code stuff. You can call me. I'm accessible, okay? I hear you, Elwood, I hear you. So, hold on, let me show you something, what we got. Elwood, you remember these? Hey, Brian. Always back for more. I love Brian. All right, so look. Here's the donation lamps, I like to say. I don't like to call them flashlights. I call it lamp. Here's the donation lamp with our name on it, and it's got the 3 LEDs, I'm going to drawing tonight for if you make a donation in the chat using the little button with the money sign on it, then that covers the shipping of things that we send, especially the free stickers and things like that, which we have some. I got an announcement in about 2 weeks of some new stickers. Anyway, so this is pretty neat. It's a magnet. It's plastic, but it's a magnet, and it goes on the fridge. And I have one in my safe, my gun safe. But again, it's side of the car at Blake. Anyway, it's a donation. We'll be doing a drawing at the end of each night that we do it, whether it's Electrician Live with me and Jay, or whether I do one here. And that's just something to give back, thank you. People donate all the time, but, this is a thank you. And then, Ron Bo always seems to win, that's for sure. And, of course, we have our little mini screwdrivers as well. It's a little screwdriver with like 9 bits in there. And again, all about the donations. So again, you can always find out more about these if you want to donate to help our cause over on masterthec.com, or you can donate here. It doesn't matter the amount, and you can get put in a drawing. And if we draw your name at the end of the night, then you get one, and you get your choice. How about that? Whatever you want. Okay. All right. So let's get in beyond all that. This is Chris. Chris has something he stated before we get into the program. It says, I'm trying to prepare for my test, my first journeyman exam. I've been reading code and taking practice exam. Any advice for the first-time test taker? Yes. So, Chris, hopefully you listen to my podcasts or watch my other videos. I have How to Reduce Stress. It's a podcast because it's easier to listen to. And I do a lot of podcasts. So people ask me all the time on our YouTube channel. I get people who see the podcast and they go, you need to do a video. A podcast is a podcast. The only reason I share it on YouTube is because some people find it easier to listen to podcasts from that platform. Otherwise, you can listen on our website. We have a player on the website, or you can go to Spotify, Deezer, iHeartRadio, iTunes, Apple Podcasts, Google Podcast. We're syndicated on all of them. So you can listen to us on any of them. Some people like to listen on the YouTube channel. So I've got videos, but we also have the podcast there. It takes a lot more to do the videos than for me to turn on the mic and just do a podcast. So that's why I do a lot more podcasts than I do videos. So I know some people are visual learners. I get it. Some people learn because they hear something and they can get it, right? But the videos that I do for free on the YouTube channel are all supported by donations and things like that, because the funds for the courses we sell pay my staff. And they're working while I'm away working at another job. And then I get off and I come here and I'm able to dedicate time to the academy. So again, you kind of got to understand how that works. But I need you to listen to that podcast. And it is Reducing Stress. And it explains the wave concept that I actually started probably 20 years ago, and people copied it. Okay? People hate when I say that. But at the end of the day, I was talking about it a long time ago, and now it's become the concept. You need to do the exam in waves, and you need to know how to prepare for it, and it reduces the stress. But the only real way that you can reduce stress, Chris, is making sure that you know the material. Okay, so when you think about what you've done when you read the code and you've done practice exams, reading the code is one thing. Do you read the code while you're doing practice exams and use the questions to dissect the root cause, the triggers, in order to be able to read the code? Okay, so there's a concept there. It's a methodology to preparing, and I always say, don't just open the code book to try to read it. You have to prepare. You have to study with a purpose. And we're going to look at how you do that tonight. And maybe it'll help you take those questions and then go back and restudy again using those questions. Because the key to you getting better, the tip that I can give you, is the more that you flip through the index, the more that you learn what the index covers and what it doesn't, and the more that you are flipping through the code book, you're going to be successful the more time you put into it. So I tell people with the Fast Tracks program all the time, they say, how long does it take, Paul? How long does it take? I tell you, there's a 90-day plan and there's a 60-day plan. If you do a 90-day plan, it's 2 times a week for 4 hours of study. Dedicated, quiet study. If it's a 60-day plan, it's 3 nights a week of 4 hours. And you need that in order to study. Now, life gets in the way. I get it. Causes problems. I understand. I've got some people right now, quite a few that are in our CMECP program. They're probably not going to make it. And they're probably not because they're going to run out of time. Life got in the way. And they know that getting into it. It's a rigorous program. So, again, life always, last couple weeks, life has gotten in the way, and that's why I haven't done any new things. And my newsletter on code changes is behind for all those that subscribe to that. I'm behind a month. We typically go dark, we say dark on the 12th month for other reasons. But in this case, it's supposed to come out in August, but it was not coming out in July. But, Brittany was jumping on me, why didn't we put one out? And I usually don't. In a 12-month series, I usually don't in the 12th month. I do in the 13th month. Long story. But anyway, things have gotten behind, and I'm trying to catch up. That's the key what I'm saying. We have a lot of students in the program, a lot of exams that I grade. And usually I do exam grading on Tuesdays and Thursdays, sometimes quicker if I got time. Okay? All right, enough of that. So yes, my tips, Chris, is look at how we do this tonight and study with a purpose. Use the exam question to be able to dissect it, to determine once you're still going into the code, go in there with a purpose. Okay? And we'll kind of look at some of that tonight. Okay? So let's go on and do that while we're doing it if it hasn't logged off by now. And it's logged off, so let me go on and get back in the program here. Hold on, so let me get back in it. It logged me out. Oh, all right, hold on. This is a student that I just had to help get his Josh. That was your account. Sorry about that. I don't know why it automatically did it. Hold on, let me get back in. And again, if you ever have problems logging into your account, I can help you only so much. Usually I'll ask you for your user and pass, and that'll allow me to get in under you, and I can look around and see what's going on. Okay. So we should be back up here. And let's go down here and let's do some Journeyman 6. And we're halfway into it. So, hopefully you can see the questions here. Bear with me for a second. Let me make sure that I add me to the equation here, folks. So hold on for a second. Let me add me so that you can actually see me. There we go. Let me trim me down. Okay. All right. So we're going to look at some exam. And again, hopefully you can see the screen, not too much problem squinting, depending on what you're doing. If you're trying to do it on a phone, best I'm probably going to get tonight, so without losing anything. So this is an example for those that are in the Fast Tracks program, what it looks like. And let's see here. Let's see if I can add the chat here real quick. Bear with me here. I'll add the chat somewhere in here. And I don't know that I want to put it right there. Hold on for a second. Let me move it up here. All right, so we got something a little bit in the middle. We might be able to see your chats and whatnot, what you ask. Okay, so for those that are new, okay, you need to understand how you dissect the question. Now, again, I'm gonna give you a shocker. Okay, hopefully it's not a shocker, but the index in the code is not going to give you all the answers. I know it sounds like, it's a good start. So again, the premise of you taking an exam, and I usually have to explain this to students quite often, and I, again, train thousands of students. There's a certain amount of knowledge that you have in order to be able to take an exam. Certain amount of knowledge that you've acquired. So the questions are going to have certain things in them that are going to be something that you just need to understand what it is based on your experience, what you've put in. I mean, even if you are not a licensed electrician at this point, you still had to put in a certain amount of time of education. Okay, you had to put a certain amount of time of on-the-job training, right? So some of the things that you'll get on an exam, the questions are going to have to be based on knowledge that you've obtained, right? A knowledge that you have gained. And let me make this a little bit bigger, folks, so I can see it at least. And y'all don't need to see the questions. So let me do this here. Make it a little bit bigger so I can see what's going on. Okay, so at the end of the day, you have to have some knowledge of the terminologies to be able to answer the question. All right, so I beat around the bush on this one. So let's kind of look at the question and dissect it. If I'm on an exam, so it says the maximum operating temperature for a thermoplastic covered solid fixture wire. Okay, there's a lot of information here. Fixture wire is TFF. It is blank. Now, when I see fixture wire, I know that in the National Electrical Code, there's a specific article that's based on fixture. It says fixture wire. Okay, so hopefully you grabbed your code book and you've gone and looked that up. For us, we will switch over to the NEC on this question. And we're at the NEC. Now, you'll notice as you get... Now, let me say something else real quick that I probably should say. You have to get familiar with the articles. So you want my tip? I'm going to give you another quick tip for those preparing for an exam. You ready? You should either, if you're in the Fast Tracks program, you can create your electronic flashcards. If you're not in the Fast Tracks program, you should be going out to Dollar General, Family Dollar, Walmart, wherever it is you choose, and you should buy index cards. You get a pack of 500 of index cards. Get you a good Sharpie. Come back, and what I want you to do is I want you to write a flashcard for every chapter in the code. Chapter 1, general. So put chapter 1 on one side, and on the other side, put general. On another flashcard, put chapter 2, wiring and protection. Okay, put chapter 2 on this side. On this side, put wiring and protection. Chapter 3, wiring methods and material. Chapter 3. Do this for all the chapters. Okay, then what do? You do the exact same thing for all of the articles. Okay, so you'll get you a list of flashcards, and you just need to get used to looking at it and saying 250 grounding and bonding, 210 branch circuits, 215 feeders, 225 outside branch circuit and feeders, 430 motors, okay, 400s, flexible cords and cables, okay. You need to look at things like 410 luminaires. You need to be able to look at it and just know that 334 is non-metallic sheet cable, okay. You just need to look at it and be able to quickly say, oh, 680 swimming pool, 690 photovoltaics. Okay, 700 emergency systems, 701. Okay, you're looking at the different aspects of it. You need to know the difference between 701, 702 for optional and legally required standby. All these type of things you need to be able to call it, because in an exam, it's all about time management. And the quicker that you can get in the area you need to get into, or when you're looking at the index and you know your question has something about emergency, when you're looking in the back and you're looking down the index and you see 700, then you know that that's emergency or something. So it really is going to save you time. So my first big tip is to get you some index cards that are really cheap. If you're in the fast tracks, you can make your electronic cards, but get you some cards, because that is the way to go. It is definitely the way to go and how it's going to work. Okay. And I forgot what I was doing, so I'm going to go back real quick. Okay, so in this case, we know that it's solid fixture wire. Okay? So when we know that, it was type TFF. So then we can go to the code because I kind of lost track. So it's solid fixture wire TFF. All right, so I'm at the NEC, and I would know that I have fixture wire. And then, of course, you have the different types of fixture wires, and here's your numbers and everything that you have. All right. And then, of course, allowable ampacities of fixture wire and everything like this. So you have everything that is in the NEC, right? And so all of your applications are here. You've got the different types. Now, incidentally, what I want to look at is interesting here. Here's a TFF, for example, right? The thermoplastic 18 to 16, which is interesting in itself, because you have all the values, allowable ampacity for fixture wires, 18, 16, 14, 12, and 10. And here's your values. Okay, so now let's go. You're in 402. So now we'll go back to the browser. If my browser goes back. All right, so we see all the values. So now you're saying, okay, well, the question had absolutely squat to do about ampacity, but I think you should read it. Like I said, you should be reading it, looking at everything, and that's what we're coming. Before I answer the question, I gotta talk about studying for a purpose. Okay, for those that are with me, that's how we look at a question. And once we use the question to look things up, that tells us that it's in 402. That tells us how to find ampacities. All of that stuff is called studying with a purpose. Even before you even answer the question, it's studying with a purpose, dissecting it, because you paid probably good money for those questions, or you got them free online, but you probably got them. You want to make sure that you're using that question for everything possible, okay? That is what you want to do with a question. I want to get that out of the way because we're going to kind of move through some questions. So, Josh, everybody that's doing it, use this question until there's absolutely nothing left, okay? Nothing left in the question, okay? So let's go back to the NEC. And so I can tell you what ampacities are. I know that that's now in my mind in case I'm taking an exam. I know where it is now. I get it. Let's go the other way. Oh, went too far. Sorry. All right. So if I go back to here, the TFF, and I go out here and we see that it's 60 degrees C. Okay. But in the process, I have learned an awful lot about thermoplastic TFF. I've learned a lot about 402. I learned that there is an article for it. And I learned that there is specific allowable ampacities for it. All things that could come up on an exam. Okay? So that was kind of, I wanted to get that out of the way. That's dissecting a question. Okay? So hopefully I didn't lose anybody in that. Okay? So dissecting a question. And oops, why is it not 140? Oops, let me mark it here. Anybody tell me? Let's go back to the code. Let's hold on. Where's my code button? There we go. Let's go back to the code. Oops. Let's go back where it is, okay? So why was this answer, why did we get this answer wrong? 60 degrees C, 140 degrees Fahrenheit on an exam. What do you think? Anybody want to venture to guess? And we'll go back to, hold on, let me go back to the code. I'm at the code. Anybody venture to guess why we got where we're at? Let's go up to 3. Okay. Fixture wire suitable for service 600 volt unless specified otherwise is 3. And if you go down, you'll see we have TF, we have TFF and an asterisk. Okay. And it says 60 and then 140. Okay. So in this question here, this is, to me, this is a poor question. Hold on, let me get back to that. I'm not sure which one we're at here. Oh, sorry about that. Okay, so, oops. It's not, hold on, let me move this. There we go. Okay, so solid fixture wire is the question. All right. Anybody care to venture? No, somebody said because it is what? Solid. Okay. Personally, I don't think that it plays any role in this question at all. The problem with this is that this was solid and this says flexible stranding. Okay. So the question was about TFF and is actually solid application. All right. So let's see here. And I actually think that is, hold on, one question that I don't, hold on here. I don't like that question. I'm going to mark that to send in because there's two prospective answers there. Okay. So if that's the case, oops. All right, that's the case. On 7262 is the codebook answer page. And so let me go to, hold on here. 262. And there is no additional reference. So occasionally you're going to get a question that could be two ways. I would have accepted 60 or 140. The only problem is TFF is typically stranded in these sizes. Okay, so the answer could have been 60C or 140F, and I would have probably accepted either example. And so I think that this is one that we send in to the folks at DeWalt, which again is a Ray Holder supplies their questions. So there's a lot of really good questions. But then there's some that are a little bit iffy. But 402.3 does not differentiate. 140 is a value, but 60C is also a value that's given there. The only difference, again, this says solid fixture wire, and it says stranded in the table. Don't know that changes anything because the insulation value is the insulation value. So I don't think it has anything to do with that. So are you going to run into some questions that are I want to use the word piss poor? Yep, this would be a good example of one. And I'm not sure if I'm cutting off the question for you guys because that's what I've been struggling with. There we go. I am, oops. Ow. Sorry about that. I'm not sure why it's not letting me choose me. Okay. All right. So the other one, I would have accepted 140 or 60 degrees C. Your exams are probably not going to be that way, okay? So let's see here. Next question, dissecting it. My key for you on the last one is to get into flexible fixture wire, get in there, and hopefully on your exam, you'll have only one right answer on your exam. Again, I don't write these questions, okay? So they're supplied through the course. I've reviewed majority of them. There's over 1,200 of them, so majority of them are pretty darn good in how they apply. That last one was a bit iffy. Okay. Now, where a motor has a temperature rise of 46 degrees C indicated on the nameplate, for the purpose of selecting an overload device, this device shall be selected to trip at no more than blank of the motor's full load current rating. Assume that the value selected will enable the motor to start without tripping the overload device, and modification of this value is not necessary. All right, so this exam question is giving you an awful lot of information. But the one key thing we need to know about here, and you've probably watched it in my motors video, and that is you have overloads, and overloads use a nameplate. For the overload, everything else uses the value FLC in the back of 430.248, 249, and 250. Right? So this question is asking me about an overload. So first thing that I would know based on your working it, and again, we're going to dissect it, is that this is obviously a motor question. So you should know it's 430, right? And I can't even see what Elwood put there. Sorry. Maybe I should bring up I got so many screens open. I don't want to do, okay, percentage. Sorry. I see what you did, Elwood. My bad. So the key thing here is we know it's an overload. And so in order to find overloads, one of the ways, since this question, if you get familiar with 430, one of the things that you can do is when you go to the code and you go to 430, tip for you new guys. This little figure is beneficial. If you're in a state that allows you to write in your code book, and you need to check with your state, Texas allows you to write in it, other states do as well, permanent ink, like a pen, then in these spaces here, you could actually put, again, the article that it's dealing with, okay? So, for short circuit ground fault protection, 430.52, you could write that right here. But again, you have all the parts. So again, that's just another step that you could do. And then up here, you have the code references as well that align with these parts. So they work together. So for in our case, we're talking about an overload, right? So motor branch circuit overload protection starts at 430.31 through 430.44. Okay, so I know that it starts in part 3. And so I'm going to probably go to 430.31 just to get the start of what we're dealing with. Okay, but I didn't have to go to the index for that. Okay, it's just using the value. So here's part 3. And here's the general rules, and that just gives you the general information. And there's information for continuous duty. Always assume the motors to be continuous duty unless they state otherwise, right? Okay, so in this case, we go back to the question so we can look at the question. And we know that it is a 46 degrees C rise, okay? So it's a rise of 46 degrees C. And it's looking for a percentage. Everything else really doesn't benefit us at all, okay? Didn't give us any other values to worry about. It just gave us the 46 degrees C. If you get this on an exam, then you got a good start, because at this point, we're going to go back to the code, and it's 46 degrees C. And in this case, again, we're dealing with a separate overload device, okay, separate overload, and we're going to utilize values. So now, it didn't say anything about the service factor, so in our question, it doesn't have any role in it, okay? It did say for motors with a marked temperature rise of 40 degrees C or less, you do 125. Okay, so it didn't say anything about the service factor. We said we had a 146. So in order to be 125, it had to be 40 degrees C or less, and ours was 46. So since it didn't say anything about this, okay, it looks to me like that would be my answer. Okay, so let's go back to the web browser and see if that is an option for us. And it looks like oops, I keep doing that, folks, sorry. And it looks like we have an option for here. And so that is where we got the 115%. Okay, now if I go back and look at some of the things that everybody posted, I see some people with 130. I see some people with 125. And I see a couple people with 130. Okay, so again, taking my time on this one with you. You have to look at the question. Now, notice that it said, this is for you all preparing for the exam again, obviously. It said that it would start with no problems. There was no breaker tripping at all. Okay, so this is where you would go to that question. Okay, now, what if it said that it wouldn't hold? What if the question, again, it's a theoretical question, right? What if it said that it wouldn't do it wouldn't handle the load? Okay, then what do? Okay, well, let's just kind of go back to the code real quick because I want to make sure that we cover it. And if it doesn't hold, then you go down here to the selection over current device right here. And that means the same situation could be either 140 or 130. Same rules apply here. If it said that it didn't hold, but everything else stayed the same, the 46 degrees C, then again, it would be 130. But you only get to see, okay, you only get to see when it says that it's not sufficient to start the motor, okay? So as you see up here, A1, and you get down here, see how it says A1 right here? It won't let me highlight it, I guess. That's crazy. That's crazy, old PDF. Anyway, you see there, when it's not sufficient, then I can use these values. So don't fall for that on an exam. Just make sure that you don't fall for that. And again, if you only can get to C if A won't hold. So again, if you can write in your code book, in some states you can, some states you can't. What I tell people to do is, and I might tell them to write something here. I might say, well, it's not going to let me do it. Never mind. I was trying to see if it would let me make a mark in here, but it won't. That's all about signatures. Over here, I used to make a little mark here. I said, right here, it says overload, initial, and then over here, I write overload will not hold. Or if you can write in your book, you can write arrows and do arrow from here, and you can put will not hold load, then you can draw an arrow and bring it down and point it to C. Just so you know, okay, that you got to go from A1 to C if it doesn't hold. But the question's going to tell you that, just like our question did, okay? Hopefully, I'm trying to go a little slower tonight. I do have people that tell me that I go way too fast. So I'm trying to, okay. So in this case, if it said it didn't hold, you're absolutely right. Then you would go down and it would be 130 because the values didn't change. It's still 46 degree C rise, right? So absolutely right for you to do that, okay? Let's see here. There you go. So that's what I say, Josh. So I have a lot of students that do it in North Carolina. Some states you can write, some states you can't, some states you get used to, for North Carolina, that's why you have to get used to using the top of the code book to look at the different sections and get used to flipping the top corner of the code book they give you. And you have to get used to dissecting the questions. Again, some states we take advantage of highlighting, take advantage of writing in the book. Some states you can't. That's why I tell people it's so much easier to just learn the code and learn it and do just like we did. Do it slow, okay? I've been accused of going really fast, and so I'm trying to make an effort to slow down. So anyway, that's what I'm trying to do. All right, let's look at another question. All right, so this is an example on an exam question where they give you something and they go, it's a given, okay? So, okay, they're setting the tone. They're telling you this. They're going, okay, look, it's a given. An equipment disconnection means it's mounted at a height of 6 feet above the floor level on a remote wall and an aircraft storage and maintenance hangar. The disconnect switch is 10 feet horizontal from any aircraft fuel tank. The disconnect switch is located in blank area. Okay, so if you've been practicing, now this one you could obviously use the index, but you also know that there's a specific article that deals with aircraft hangars and things like that. That's how you get used to knowing the different articles, and you would have known. You was like, oh, what's the trigger here? Okay, well, the disconnect in the reference to aircraft fuel tanks, disconnect switch, the horizontal distance, the height 6 feet above the floor, all these things are going to play into this question. And if you're going to study with a purpose, then you need to take them and you need to use all the things that are in this question to help answer the question, okay? So again, for us, we can pop back and forth, but make sure you give code references and we'll look at it. All right, so let's kind of go into the code book and kind of dissect this out. I'm going to write some notes down because, again, I don't want to keep popping back. If you're in an exam, they're right in front of you. For me, they're not. I have to change to another screen. So it is, this disconnect is mounted 6 feet high above floor. It's on a remote wall. It is 10 feet horizontal from the fuel tank. Okay. All right, so I need to find the area. And again, I'm also using the answers. I've got a Class 1 Division 1, Class 2 Division 1, unclassified, and Class 1 Division 2. I got a bunch of answers that I can compare, right? So if I'm going to go to the end of the code, now if you don't know which article to go into, and we're going to see if we can't dissect it out. We might be wrong, we might be right. Let's see what we do. So one of the things that I would go to the index if I didn't know, and aircraft hangar. Okay, sounds like that's probably a popular topic. So here's aircraft hangars. Happens to be Article 513. Now, it could be over in 501, 502, 503. It could be something else, but we want to where we're going to feel comfortable with. And we have the classification of locations in 513.3. So on an exam, here's what I tell people to do. When you go to the index, you want to make sure that you have your scratch paper. You want to make sure that you have your dry erase board, whatever they give you. They're going to have to give you scratch paper or a dry erase board. Is that you know that it's 513 is a player. So you write 513 down, and then since you already know it's 513, underneath that, kind of in a one line, you're going to put all the code sections that you want to look at. Okay, while you're there, and you don't want to have to keep coming back here, right? So in this case right here, I'm looking for classification of location. I'm going to put 0.3 because I want to look there. And I'm looking at anything else that might be beneficial to me in here. Okay, that's pretty much it, although 513 is not a very big one. So again, might not be our ultimate location, but that's where we're going to start with, okay? Now, I want to go to 513. And again, y'all know that I hate PDFs. It's much easier to do it in a code book. Okay, so we've got classifications and vicinity and hangars. And let's see here. So fuel tanks. Okay, so vicinity of aircraft. It kind of sounds a lot like our question. Oh, I should give some more tips while we're here. So for you guys that are finding a code section, you want to use a technique that I call scanning. And that is, once you get to an area, you need to look for the bolds to put yourself in the right area where you need to be. Okay? And that's going to be important because you're not going to find all the answers in the back of the code book. Okay? So you have to be able to bold scan and look and see what you're looking for. All right. So in this case, if we're looking at vicinity of aircraft, it says the area within 5 feet horizontally from the aircraft power plant or aircraft fuel tanks shall be classified as Class 1 Division 2 or Zone 2 location and shall extend upward from the floor to a level of 5 feet above the upper surface of wings and of engine enclosures. Okay, so interesting enough, I look at this question, and let's see if I can't figure which button gets me back to code real quick. Go back to our question. Okay, so I've got some questions here that says Class 1 Division 1, Class 1 Division 1. I have a Class 1 Division 2, okay, and I see a lot of it says C2, okay. So again, you're digging in the right area. So let's go back to C2. Now, this is aircraft painting hangars in C2, and I'm assuming that you must be using I guess the 20. This is 2017 edition right here. Okay, so again, within the area, the surface area, I don't know that the question said anything about painting or painting booth. Okay, in the question. All right, and it's telling me storage hangars. So it's 6 foot high, but it's 10 feet away. All right. So, example of dissecting the question. Let's go back to the question. And I'm remembering which button I've got. And you'll notice that I chose unclassified. Everybody in our room here chose a Class 1, Class 2, a division. Somebody tell me, why do you think it was unclassified? And let me come back so that I can actually see your responses. Or actually I can, but I think y'all probably want to see everybody's responses. So let's go back to the main real quick. So why do you think it was unclassified? Carlos, Chris, James, Elwood, why do you think? Well, the main thing is that it was 10 feet horizontal. Okay, so the width of that was 5 feet, but it's 10 feet away in the question. So it's outside of that envelope, if you will. Okay, it's been moved outside of it. So, and that's the case, it's unclassified. Okay, and if we go back and look at the code again, and just to kind of see if I've got some, hold on, let's see if they give us any, not going to give us any pretty illustrations for the aircraft hangar. But vicinity of the aircraft, notice that it said aircraft maintenance in storage hangars, right? Our question said aircraft storage and maintenance hangar. That was in our question, right? So we knew that this is the one. It says the area within 5 feet of an aircraft power plant or aircraft fuel tank, and again, the questions about the aircraft fuel tanks, shall be classified as a Class 1 Division 2, and that shall extend upwards from the floor to a level of 6 feet above the upper surface of wings and of engine enclosures. Okay, so 5 feet out and extend what? 5 feet above. Our question was the aircraft maintenance and storage hangar, the fuel tanks, everything was located 10 feet horizontally. Okay? So, it's unclassified. Only classified within the 5 foot horizontal and 5 foot above the upper surface of the wings or the engine enclosure. So that's why it was unclassified. So all areas in a building that is either a hazardous location or whatnot, it's going to be either classified or unclassified. If it's not classified or doesn't fall within the realm of the dimensions that requires classification, then it's considered unclassified. And unclassified is just as normal as every day. Okay, it's nothing special about the requirements there. Okay, it's an unclassified location. It means it has no class. Okay. All right. Again, kind of long in how I explained that one, but hopefully you get it. It was actually outside of the 5-foot area. Okay. Let me make this smaller. Okay. So as you see the question again, that disconnect was 10 feet from the fuel tank. It had nothing to do with paint. Okay. Hopefully you got that question. Not an easy question, but hopefully you got it. And you'll notice it didn't change from 2017 to 2020. Okay, at all. All right, let's see here. Let's do another question. Let y'all try to answer another one here. Okay. Okay, good question. Let me make sure I'm not blocking anything. No, I'm not. Okay. So, and this is how you should be. Again, people ask me, when I do this on Wednesday nights, I'm not here to give you the answers. I'm here, just like you, to try to look it up, to try to dissect it. Okay? It doesn't do me any good to just spit out the answer. It doesn't do you any good. You need to look it up. And that's why we do this on Wednesday nights. Okay? It's not the same as, as anything else. Not the same as Electrician Live. This is, again, it's just trying to get you to maneuver through the code book. And I'm just opening up our Fast Tracks program to be able to help you. So in general, a general use fuse switch used as a disconnection means for a 25 horsepower, 480 volt, 3-phase AC motor with an FLA of 32 amperes indicated on the nameplate must have an ampere rating of at least what? Okay. What do you think? Give me some thoughts here. So again, this is a general use fuse disconnect. All right. And the rating of the disconnects, it's a 25 horsepower. Now, look, the first thing that I want to remind people of is that that FLA of 32 amps on the nameplate is wonderful. But pay not a whole lot of attention to that. So first thing I want to know is, who can tell me what the FLC is for this 25 horsepower, 480 volt, 3-phase motor? Just where do you go and how do you know where to go? Remember, you know it's motors. Okay. You know there's a motor application here that's going to give us some values that we need to be worried about. All right. So we'll start with that. So it's okay. So I've got 34 amps. So I guess James pulled that from the back of the book, and I'll do it with you. James, we'll do it together, but I want y'all doing it. So definitely pull it back. So let's go to the code. Just like James did. And we're going to go to 430. And I like to go to 440 and then go back one because, again, it saves me a lot of time. And I'm all about saving me the time. So, again, in this case, we would use a 460. Again, you notice that you say, well, the question says 480. Yeah, but up here it tells you that the indications of voltage ranges is still fine. It's again, permitted for the system voltage ranges, 480. So you go with 460. That's typically what you'll get on the actual motor itself. So the circuit is 480 volts application. Okay. All right. So let's go back. I have to make sure which one I'm on here still. Okay. So 25, we have, like James said, we have 34, and that is the FLC. Okay. All right. So that's one area that we would go to. So once we're back in motors, now in motors here, you have all the information here that you need as far as motor disconnection means. And here you're in part 9. And it looks like that starts at 430-101. Because you could go in the back of the book as well if you wanted to do the back of the book. We'll go this route. And we'll go to 430-101 to start our journey. So here's our disconnection means. All right. Values. All right. So somebody let me see if anybody's got the next step. and where they're going to get their values. Okay. And I'll go back to see what we've got to make sure I'm still in the code. Okay, so we're dealing with a disconnection means. And then we're going to get there to the beginning, and we're going to do bold scanning. And we're going to look for what we're trying to get. We're trying to get a rating, okay? We're trying to get a rating of whatever this disconnect would be for this motor, okay? And we'll go look at the index and see if we can find it that way as well. But for me, when I go to bold scanning, I'm looking at disconnect. So at least I jump-started my mission, right? Let me show you. I jump-started my mission by getting me at least here, right? And then I'm looking at location. Isn't a location question. This is called bold scanning, folks. That doesn't help me. I'm on an exam. That doesn't do anything. Okay, that doesn't do anything. That's readily accessible. That talks about every disconnection mean. Types. Doesn't help. Doesn't help. Okay, you keep hitting the bolds till you get down to ampere rating. And then you'll notice it says a disconnection means for a motor circuit rating 1,000 volts, nominal or less, shall have an ampere rating not less than 115% of the FLC. All right, so the question gave us an FLA, and just so you know, that value, let me get back to the question here. That value was simply to do what? The value is to simply to say, well, maybe you should use the 32. And if I use the 32, I'm going to see if that answer happens to be here. 32 times 115%. And no, it doesn't look like times. No, 36.8. So you couldn't have gotten the answer with that even if you had to use the 32. Okay. Okay, so again, our values at the 34 is 39.1. So it's 34 times 115% is 39.1, and you dropped 0.1, so we would go with 39. Okay, now, what do you think? So did everybody think? Everybody happy with that? All right, so let's go to the question, and we'll say it's 39, and it walks you through it again, and this is exactly what we just did, and I'm hoping y'all can see that. I'm sorry, I don't want to block anything. Okay, so that's what we did. How did we get there? So could we have gotten there and this is what I'm talking about studying with a purpose, guys. Could I have gotten there by going to the index if I didn't know? I don't know. When I say study with a purpose, that's what I mean. So we're going to go to the code. Let's go to the index. And let's go under motors because we knew it was motors. So let's just go under motors and see. And again, I hate this index for me. Bear with me, guys. Well, okay. So we're at M's, and you're going to do it much easier in your code book than I am in the PDF. And so we got motors. Okay. So we know that we're in motors. And we're looking down and we're seeing, is there anything in here that would have gotten us where we needed to be for the disconnection means? Okay. And let's see here. Overload. Disconnection means. Okay. So you're asking me, yeah, but Paul, it gave me 430.75, 430.95, 430 part 9, which is where we needed to be. 430.128 and 430.227. Okay. All right. Well, it might not have pinpointed me down, but it got me where I needed to be inside of 430. And I probably would have written down, if I didn't know any better, I probably would have wrote 430 down. Okay. The pen doesn't work. Let's get another pen. I would have wrote 430 down, and underneath it, I would have dot 75. I would have done dot 95. I would have done part X and dot 128 and dot 227. Okay. I might have done that. And then I would have finished looking and seen if there's anything else since I'm here that would have been, that pertains to what's in the question. Okay. And I look down, and just while I'm here, and to see if there's anything that would have been beneficial, that would have drawn me to it. Okay, well, it says disconnecting means. And here I see 430.109G and 430.110. All right, so that could have gotten me, and I would have probably wrote that down, because as long as I'm in 430 and I'm in that area, I'm going to write it down, because I don't want to make a million trips back into the index. I want to get what I need. That's why you have the erase paper there, dry location. The dry erase board. Do it. Now, while I'm here, and this is what I say, use the index to learn. The more you spend time in here looking things up, the better you'll be at flipping through the index. Now, I want to go to disconnection means and see what it says under disconnection means, and let's see here. So here is, bear with me as again I'm going through this scrolling here. Okay, disconnection means. All right, so I would have gone down through disconnection means to see if there's anything that's beneficial to me. Now I'm going to answer so here's motors. And motors gives me the exact same ones that I just got when I was over looking under motors. Okay, so the same exact information there. Keep on looking down. See if there's anything else that would help me out. And no. So it's the same information. Would have gotten it by two sources. Okay. Now, once you get there, just for craps and giggles, I probably would have gone to the 0.75 first. So again, I'm going to go through here and go to the 0.75 real quick. And the moment that doesn't answer your question or have anything that you know that there's a percentage involved here, then you know that 0.75 is dealing with motor control circuits. I'm immediately leaving that one, and I'm going to the next one, 195. Okay? Hold on here. So here's the 3075 disconnects. Okay? And that's the motor control circuit that wasn't with my question. So the next one was the 95. And 80... 89, 90, 90, and this is under motor control centers. That would immediately told me that's not what we're dealing with, so I would have moved. Okay, so service equipment has nothing to do with what we're doing. I would have immediately gone to the next one, which would have been part 9, right here, and then I would have been bold scanning, and then that's where I would have found right here the ratings. Okay. And of course, the other way I found it was able to find it, and it told me disconnects under 110. So I could have gone there as well. All right. So key thing to remember, 115% rating for your disconnects for motors. If it's going to service the disconnection means, it has to be a minimum size, and that's of the disconnect. Okay. The rating of the disconnect. Okay. All right. So anyway, that's how we just dissected that one. Let me go back to the browser. And that's how we would have, kind of worked that question out. This part of the question meant nothing to me. This just helped me. I mean, this was 480 volts, but really you need to know that the motor is going to be a 460 in the table. 25 horsepower helped me. Nameplate didn't do anything for us. Simply a pull from the code. Okay. And then the other thing here is you notice that it says table 430.250. That's interesting. Let's go look at the NEC and look at 430.250 as well. And here you see this is what we used earlier to get the 25 horsepower and the 34 amps. Okay, so I just want to tie that all in so that you can see where we got all that stuff for those that are new to motors. Now, if you haven't watched my motors video, I encourage you to go watch the motors video. I go really quickly in it, so I'm trying to make an effort to slow down, but there you go. All right, the next one. Give it a read and work it out. See what questions you get. And then we'll dissect it a little bit and do just like we did. Enclosed construction of a manufactured building. Okay, closed construction. Not altogether sure what that might mean, but it's obviously something in the question. It says, manufactured building, what is the maximum size cable that may be used without additional supports between boxes? Okay, so manufactured building is kind of a trigger. There is an article for that. So what does somebody think? So A, B, C, or D? What do you think? And give me some numbers and give me some code references and look it up. And we'll see how we find this. Another thing to tell you that there's a lot of bad data banks out there, good and bad. Some questions are really bad. Some of the questions in here could use a little more work. But reality is, even a bad question is not a bad question if it gets you moving through the NEC. And that's really all you're trying to do. You're just trying to learn and look everything up. Okay? Carlos gives us a value here. He's picked his answer. So if I'm dissecting this one, then I'm looking at, I'm thinking, manufactured building. And I've got a bunch of wire sizes here, which I can use as triggers once I get to where I need to be. And the question is about what? It's support between boxes and without additional supports. So maximum size cable. So manufactured building. So I'm probably going to go to the NEC if you don't know the answer. And I go to the NEC. And I'm probably going to know, and this is why it's so good to create your flashcards. Let me close this down real quick. There. So good to build these flashcards because you get to learn where things are. And it just, at the end of the day, you get faster at it. Okay? All right. So we're here in manufactured buildings. Okay? And manufactured buildings is pretty small. All right? So I'm going to look for triggers. And triggers for me on an exam is the answers were as a wire size. So if it's a pretty small article, and I'm telling you, it's pretty small. Let's look at it. So there's, that's it. It's about a page and a half. So on an exam, I want to learn this stuff, but again, if you're on an exam, your time is limited, I'm going to hit the bolds. But I'm also going to remember triggers, and the triggers was a wire size. Obviously, the question had to have something to do with wire size. So as I'm scanning this, I'm coming down and I see this value here. And I'm looking quickly to see if there's any other wire size values. Okay? That's kind of how I teach it. And then you can learn from it. But I'm looking to see, and I don't see anything else. Okay? So I'm going to pull back, and here's what it says. Securing cables, kind of what the question was about. It says, enclosed construction, ding, 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 ding. Okay? Cables shall be permitted to be secured only at cabinets, boxes, and fittings where 10 or smaller conductors are used and protected against physical damage is provided. Okay? Now, reading the question. Cables shall be permitted to be secured only at cabinets, boxes, and fittings where 10 or smaller. Okay? 10 or smaller are used and protected against physical damage. All right? Let's go back to the question. Enclosed construction of manufacturing. What is the maximum size cable that may be used without additional supports between boxes? And I've got 10, 10, 10 as my answer. Okay? So we'll go and choose 10. And there you go. And again, it's 545.4b. Worded question. Okay. No additional supports. Nothing additional is required. 10 gauge is the maximum size. We use that as a trigger to be able to find it. Okay. Next question. God, I'm making sure I'm not blocking you guys. No, I'm not. Okay. All right. Now, where a single 125 volt single phase 20 ampere receptacle outlet located in a attached garage of a dwelling unit is provided for a central vacuum assembly, the receptacle outlet is required to have blank: a non-metallic faceplate, an AFCI protection, LCDI protection, or GFCI protection. What do you think? A, B, C, or D? Couple things that we got to remember. It's single phase. It's 20 amp receptacle outlet. Okay. It's 125 volts. And it is in a dwelling unit. And it's just a dedicated receptacle for a central vacuum. So what do you think? Okay, I've got an answer on the screen. And so let's kind of dissect this question. All right, first things first, it is a garage. And I'm seeing pretty much consistent answers here. Okay, now I will tell you something. In the 2023 code, this might change because there's an effort out there to require AFCIs to be everywhere. Everywhere. So the first way that I quantify this is, let's do a process on an exam. But AFCI is not required in 2017 code, by the way. So who said that? Anyway, Chris. So it's not required in garages. But if I was on an exam, the first thing I want to do is reduce my odds to a better than normal chance whether I got a guess or not. And again, if you watch my thing on reducing stress, you do things in waves, right? So a non-metallic faceplate is irrelevant. Throw that out. The LCDI is irrelevant. Throw that out. Okay? The answer is either AFCI protection or GFCI protection. Now, you know it's in a garage, and you know all receptacles in a garage require GFCI protection. So unless my answer said AFCI and GFCI protection, and it doesn't, it has AFCI or GFCI, you could have answered this one easily without even looking it up, and it would be GFCI protection. However, for an exam, in case you get something like this that you do not know, and you've ruled out the obvious, it's not a non-metallic faceplate, it's not LCDI, your options are AFCI or GFCI. The quickest thing you can do is get familiar with the different articles and the different sections. I would have gone, let's say, just for craps and giggles, I've narrowed it down to 2. I'm going to go to AFCI's 210.12 because you learn that that's where it is. And I'm going to see if it says a thing about garages in there. Okay? And obviously I chose that one for a reason. But we'll go there, and I like to make it hard on myself. So we'll go to 210.12. Guess we could have stopped at 210.8, but we skipped it over it. And let's look at 210.12. And it's AFCIs. And look in here, it says dwelling unit kitchens, family rooms, dining rooms, living rooms, parlors, libraries, dens, bedrooms, sunrooms, recreational rooms, closets, hallways, laundry areas, or similar rooms. Those are similar to these type of rooms. A garage is not listed here, and it's not similar to any of these unless you converted it without permits, and nobody knows that, and it's a violation of your local ordinance anyway, but we won't go there. So, again, if you didn't know that it was GFCI or AFCI, you could have ruled it down to 2. Go to either one of them, and you could have gotten the answer that way. Okay? So, again, why did we do it? Personally, it's because I want you to go to 210.12. Now, remember, people say, well, Paul, on an exam, I can't take that much time. Look, I will say this till I'm blue in the face. You're studying for the exam. You don't wait until the last week to start timing yourself. Okay, last week or 2. At this point, you take the time you need to look up the questions, dissect the questions. There is a method to the madness. There is no shortcut. Again, people will sell you on a weekend crash course and tell you that they've got the answer to pass an exam. They are lying to you. It's not how it works. I've trained enough students on this. Take your time, okay? All right, so we'll go answer the question. We'll do GFCI. And there you go, 210.8A2. I saw some references in there, so very good. All right, so we got a 92% on that one because we got a bunch of them wrong at one other time. So let's kind of go in to do a few more. All right, and let's see here how well you do with some of these questions here. All right. Now, but I should say, if you have any questions on anything as we're into this, feel free to ask. Now, Josh, I will tell Josh, because if Josh, you're still here and you're doing exam prep and you're in the Fast Tracks program, these questions at the bottom, you do one a week, but you need to stay in the course, do each unit, do all the competency reviews, read the material, don't move forward, do one unit at a time, submit the questions, and be very focused on the program. Okay, don't jump around. All right. Now, you can do one of these exam practice quizzes every week. Do at least one. Okay, and if you don't do as well as 60%, do it again. Keep doing it until your scores are above 60%. I'd like it to be in the upper 80s to lower 90s in order to have a good chance of success. Okay, but again, don't get flustered. Okay, work through these questions. Some of them are good, some of them are not as good, but there's a lot of them, okay? All right, in regards to artificially made bodies of water. So first thing you should know is if it's an artificial body of water, there's an article that deals with that. Now, you could probably look at the back of the index under artificially made, and you probably will find the answer to this, or you will find where it needs to be. Many people also refer to this as natural bodies of water. Things like that. But again, artificial made bodies of water, liquid tight, flexible, metal conduit, LFMC, is a wiring method permitted for use for a feeder or branch circuit where flexibility is required. Which of the following listed wiring methods is also approved for this use? Where's the use? It is in an artificially made body of water. So, go into your code book and let's talk. And again, we're asking what type of wiring method can be utilized for flexibility. Okay, so let's go to the NEC. And let's assume you didn't know that there's an article dealing with this. Okay, so assume you didn't know. We're going to assume you don't. And we're going to go to the index. And when you go down to the index, and you want to see if there's anything that has to do with, that says anything about an artificial body of water, because that's what we used in the question. So we want to see if it says anything about artificial bodies of water. One good thing is we know a couple things. One, that it's probably going to be in chapter 6. Okay. And you say, well, why is it being, because that's special equipment in chapter 6. So we know it's probably going to be in there, but let's see. Here we go. Artificially made bodies of water. Well, of course, like I said, usually we call it natural and artificially made bodies of water. So this is sending you into national. That's okay. Guess what? Because you did this, you now know. And you know that there is such a thing as natural and artificial bodies of water. So we're going to go to that. And next week, guys, I think I'm going to do a calculation, some calculations for those that want some calculations. I think I'm going to do that next week, so make sure you come back next Wednesday, and we're going to do some calculations. Bear with me while I hate PDFs. Oops. Okay. So let's see here. Neutral, I've gone too far. Okay. Natural, artificially made body of water. We know that it's Article 682. And we have installation, and that is under Part 2. And installation is going to give us the different types of wiring methods. So we know to go to 682, and we know that it's not very big. Okay, look at it. It's not that much there. Okay, so we're going to go right there. So 682. And of course, if you tab your code book, there's probably a tab for 682. Maybe not 682. I know there's one for 680. Okay. All right. So wiring methods. So we get here, then we do what's called bold scanning. Get familiar with hitting the bolds in order to see where the answer is you're looking for. We know that was part 2 installation, and we're looking down, and another trigger is the type of wiring methods. And here it is in 682.13, and it says liquid-tight flexible metal conduit or liquid-tight flexible non-metallic conduit with approved fittings shall be permitted for feeders and where flexible connections are required for servicing. Okay? All right. So we've got some additional things. So we don't want to stop here. We want to go back and look at the question again. And you're going to have it with you. I don't, so we got to go back and look. Okay. So we've got nowhere in here that says, okay, so it says FLMC is permitted for use. Okay. That's already covered. The only other option here is extra hard usage portable power cable. So that's already telling us that LFMC can be used. Of course, it doesn't tell us that LFNC can be used, but it can. So we're just going to go back to the code book and quantify this. And we see the extra hard usage cord. I don't see anything in here about those other wiring methods that were listed there. Okay. So on an exam, I'm ready to go, and I'll go back to the browser. Sorry, I got to get back to the screen I'm on. In this case, it looks like that's the answer. Now, why did we look this up? We looked it up because we wanted to know LFMC was already listed. What else is there? None of these others are listed here for this application. Okay, so we are going to choose the obvious choice here is extra hard usage power, portable power cable. That was listed in the code reference. Okay, check this one out. Enclosures in a, hold on, make sure I'm over there for you. Yes, okay. Enclosures in a class 1, division 1 location containing components that have arcing devices, okay? So inside of this location, we have devices that are going to make and break. It's going to create an arc. They're already telling us this, okay? So there you go. It's class 1, division 1. We all should know that class 1 is flammable gases and liquids. Division 1 means that they're going to be present all the time. And so now I've got a freaking device that's going to generate a spark. This can't be good, right? So again, kind of understanding this and dissecting the question. It says, must have an approved conduit seal located within blank inches of the enclosure. Remember, this is an enclosure with a device inside that creates an arc, okay? Or as required by the enclosure marking or each conduit run entering or leaving such enclosure. So now we have a distance, 18, 12 inches, 30 inches, or 24 inches. And what is the question? Important to read it. It's the seal off that has to be located so many inches from an enclosure that's containing an arcing device, right? So first things first, it is class 1, division 1. You need to know what article that is, all right? Now, hazardous location comes in many flavors. You have 500, which gives you the general. You have 501, which is going to be class 1. You got 502, which is going to be class 2. And 503, which is class 3. Class 1 is vapors and liquids, flammable. Class 2 is going to be combustible dusts. And in 3 class is going to be easily ignitable fibers or flyings. So you need to get used to that. So create those flashcards. Flashcards. Now, let's say you didn't know any of this. You could go looking through class 1, but now that you know there's a class 1 division 1, and you know you're looking for seals, how about this? If you don't know anything, and I'm looking for you guys to look these questions up. Question. What tabs do I recommend? Be honest with you, I recommend the easy tabs. If you're going to get them, they're color coordinated. There's red, blue, yellow. It kind of breaks them up. I like those. I just like the easy tabs. If you want to get a link to where you can get some recommended ones, you can go to our website, or actually go to electricianlive.com. There's a recommended products page tab, and I give a list of all the different things that I recommend for exam prep, and you can get them there. Again, I'm an Amazon affiliate, so it's not going to cost you anymore, but I make a penny or two. But anyway, easy tabs is the best ones that I recommend. Okay? Now, let's tackle this from a perspective that I don't know the answer. Okay? Okay, so I've got some answers coming in, so good. Y'all are looking it up. So let's tackle this if you were a student and you didn't know. Remember, I'm going to have a scratch paper, and your question's going to be right in front of you. But for me, I'm going to write this down. So it's a Class 1, Div 1, okay? And I know which article it is, but let's assume we don't. And we know that it's an arcing device that's in there. And I'm looking for the conduit seal. Okay, that's all I've got. So now I'm going to go to the NEC, and we're going to go with an angle. And when I say study with a purpose, this is what I mean. Go look it up. So I'm going to go to index and assume I didn't know. And I'm going to go to Class 1. So I'm going to go into Class, and I'm going to see Class 1. So here you see that it says hazardous locations. So that saves me a time. I'm going to go down to hazardous locations. All right, here's hazardous locations. And that's hazardous location Class 2. I don't want that one. I want hazardous locations Class 1. Okay? So now I'm looking down here and I'm going, okay, what is the question about? The question to me is about sealing. So here's sealing here, okay? But this is 505, and everything. You're thinking, okay, well, how is that helping me any? That's 505. That's kind of put me outside of a realm. I know I'm looking at hazardous locations, and it should be where? Where should we actually be for this application, okay? So this is dealing with Class 1 zones. Doesn't help us any. So don't fall into this one. And that's 505. Hey, well, look at here. Here's a Class 1. All right. And let's see here. Let's go down a little bit. Sealing. 501. So what am I going to do for an exam? I'm going to write 501, and I'm going to write 0.15. And then I'm still going to write 0.17. Might be beneficial or not, but I'm still going to write it. All right. And I'm going to look while I'm here because, again, I'm going to look and see if there's anything else that's relevant. All right. And pretty much that's it. Nothing else that I need. Look and see if there's anything else. Nope. I'm good. So now I'm going to go to 501.15. Here's 501. You'll learn that that's Class 1s and 501. Again, flip cards. Make those little index cards. Greatest tip I can give you is those little flip cards. A great way to make those. All right. So I'm going to go down to 15, sealing. Okay. So conduit seals. Class 1, Division 1. Each conduit entry into an explosion-proof enclosure shall have a conduit seal where either of the following conditions apply. The enclosure contains apparatuses such as switches, circuit breaker, fuses, relays, or resistors, all of which create arcs, sparks, and things like that. Okay? So we have enclosure here, right? And you say, okay, that's the first part of the rule. And then you keep on going down, and that just is giving you a bunch of info that you got to meet. And there's exceptions to the general rule, none of which are in our case come into play. And you'll notice it says for entries, sizes 2 or larger, and for enclosures containing terminals, splices, and taps. It gives you some more information down here, but then it says conduit seals shall be installed within 18 inches from the enclosure as required by the enclosure markings. Okay? So I see 18 inches, that was part of the actual question. And I don't see any 2 or more. That really wasn't part of the question. So I am pretty much at that point going to feel like I'm pretty confident with my 18 inches. All right. So I'm going to go back to the code. Maybe I'm wrong. Let's see here. We'll choose 18. And that is correct. 501.15A1. Okay. So A1 is what's going to tell us that we have to comply with all the rules for entering an enclosure. Okay. Hopefully everybody got that one. Let's go back. Okay. All right. The next question, let me get back to the code book because y'all can't see what I just did. All right, so dissect the question again. And I believe everybody got 18, 18, 18. Very good. That was an easy one, obviously. So now, which of the following wiring methods is or are approved for use for fixed wiring in an area above a Class 1 location in a commercial repair garage? Okay, so it's a commercial repair garage. Class 1 location means that obviously it's going to have gas and vapors. But this is a wiring method that specifically, now, it says a commercial repair garage. What do you think? Okay. So we're looking for any of the fixed wiring. What's a fixed wiring method? So EMT, rigid, IMC, those type of things. Those are all examples of fixed wiring type of methods. Okay. MC cables could be, AC cables could be a fixed wiring method. It's fixed in place, secured in place. It's not portable. All these type of things. So any of these could be the answer. Could be all of them are okay for it. Not sure. You have to look it up. So commercial repair garage is a trigger. Obviously, Class 1 location is a trigger. All right. And we're talking about areas above the Class 1 location in a commercial repair garage. Is it a possibility that commercial repair garage is a defined term that we might be able to look up in the code? Quite possible. Okay. So guys, give it a look. Again, for those that are new to this, when we do this, again, one night I might teach calculations or might teach something else, but when I do the ones where we look up the code, I really am hoping that you're grabbing your code book. And it doesn't do me any good to just give you the answer. The whole purpose here is for you to look it up. That's why I tell people in the Facebook, bring your code book. I want you to do the work. Okay? Excellent. Everybody's looking it up. Very good. Okay, so let's do the work. Right? So if you didn't know this, we'll go to the code book. Okay, so we're in the code. Again, 2017 code. Really wouldn't matter whether you're using the 2017 or the 2020. Doesn't really matter. And if I was going to the index and I didn't know that there's an article that deals with that, I might go looking for commercial and seeing what it has. Commercial repair garage. And let's see what it has. Seems pretty, so we have commercial garage. It says see garages. Okay. So I'm gonna go down and make sure I'm missing anything. Okay. I'm gonna go down to garages. Again, I'm also showing you how to use you might already know this. So again, we have different levels of people that come to this. If you already knew the code reference, then you could go there. But I'm showing you from the basic bare bones of how you use an index. Because the better you get with an index, it's not the holy grail. It is not going to always be the right answer, but it's going to hopefully get you in the right area. And sometimes you're going to have to use terminologies that you're familiar with to help get you in the right area. Okay, so here's a commercial garage, and we see classification of location, which is kind of what we're talking about. So I'm probably going to write that down. I'm going to write 511, and I'm going to write. Why my pen? This is what happens when you buy cheap pens, and I buy them by the thousands. So But if I ever give you some of my pins, I'm not going to call them cheap, just so you know. All right, so 511. So now while I'm here, I'm going to look and see if there's anything here. I've got locations in 511.4. So I've got .3, I've got .4 that I want to look at, gets me where I need to be. And then I got the wiring. It's in .4 and a .7. So I'm going to add a .7. So that's my information. So now quickly, I'm going to go to the code book as quickly as I can go with this device. Now, if you had a thing, you would have known, right, that you have 511. So we're in 511, and so you've got repair garages, and its first one was .3, and classifications here. It says area adjacent, blah, 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 vapor, blah, blah, blah. Okay, doesn't do anything. All right. .4, that was on our list, says wiring within class 1 locations as classified in 503, the wiring shall conform with the provisions of 501. Okay. That's equipment located in it. And what's the other one that we want to look at? Okay. That's the .7 one, says wiring and equipment installed above a class 1 location. Okay, seems pretty good here. So it says, all fixed wiring above a class 1 shall be metal raceways, rigid non-metallic conduit, electrical non-metallic tubing, flexible metal conduit, liquid type, blah, 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 shall be MC, AC, MI. Okay, so at this point on an exam, I am pretty much feel confident. So we'll go back to the code. And as you folks so diligently did, all of these methods are acceptable. But again, looking it up, not guessing, not taking a wild, guess, but taking it and spending the time in dissecting it, just in that small amount of time, you have a much better knowledge of commercial garages, better knowledge of what can be above a classified area. And so again, if it's above a classified area, then guess what? It's in an unclassified area. In that case, the code is going to allow you a greater latitude of wiring methods to be utilized. Okay? All right, next question. Y'all are doing great. Let's see here. Where a office building has a 208Y 120 volt 3-phase service with a balanced net computed load of 90 kVA, what is the approximate current each ungrounded phase conductor carries at full load? I got a bug on my screen. Sorry about that. The bug was running across the screen. All right, so what do you think? Again, it's telling me that it's balanced. Okay, it's great to know. All balanced. It's 90 kVA. I will remind you that it said it was a 208 3-phase, and it wants to know the current ungrounded phase conductor. Okay, what it would be. So work your math and post your answers here, and we'll work through it. So this is a very common type of question you would get on an exam. There is a calculation involved here, a very minor one, but there is a calc that you have to deal with. Okay, so first thing that I want to remind you, it's 3-phase. Should be a trigger. Okay, see some answers coming in. So let me work it out myself. In that, hold on, and then it's okay. All right, I know what my answer is. So I see one answer. I can tell you on the screen, there's a right one and there's a wrong one. Okay, is this an easy way to say that? There's a right one and a wrong one. Okay. Now, I'm going to see where somebody would have gotten the wrong one here. Let me see. Yeah, I don't know where that would have come from. All right. So, one thing to remember, guys, and we'll go on and answer it, but one thing to remember, it looks like the consensus is 250. So we'll go 250. Key to remember with this question is that first things first. I told you it's three-phase. So we're doing a load count, okay? And so in this case, it's telling us it's 90,000 VA or 90 kVA. We want to turn this into VA. So we take the 90 times 1,000, or you should just know that 90 kVA, the K means 1,000, so it's 90,000. Remember I said it was three-phase? So three-phase is dealing with it. Again, you're not going to use the 120. You're going to use the 208 because it's dealing with the service, okay? And so in this case, it is 90,000 divided by three-phase, which is going to be the square root of 3, which would be 90,000 divided by 360. And I use 360. You can do the exact square root if you want, 360.25. And I usually drop the 25. And so in this case, it would be 90 divided by 360, and it's 250. It's exactly the same way you would do this if you're doing a service for a commercial building. You're not going to do it by 120. You're going to do the service by whatever the service rating is. If it's a 120, 240, you know that single phase, you always use 240 for services. In this case, it's asking you for a service value. You're never going to use the 120. You're going to use the higher value. But you still got to know that it was three-phase, and you got to remember that I need to do the 1.732 for three-phase loads. And so that's how you would work the question. So again, in this case, it is 250, all right? So, again, in your 0.82, if you did get 249.82, you know that you round the code, and that's not one of your answers, so you're actually going to round it up to 250, and that would be the best choice there, okay? Very common on an exam. Just really, in fact, in Texas, this is actually a two-step calculation. So this would be under the calculation part. If you get a bunch of these on the exam, be happy, right? Be really, really happy, okay? So anyway, there you go. And it's also important, it says it's the balance and net computed load. So again, the load is 250. Remember, even though it is three-phase, it's still alternating current. So again, there's people out there that believe that 250 on each one means a 750 amp device. No, it's 250 for each conductor. It's a 250 amp overcurrent device. Okay? All right. Okay. Now, you can't take a 250 amp device and get 750 amps out of it. It's not going to work. All right? All right, so let's look at another question. But very good. Very good. Everybody did pretty good on that one. All right, come. You can't wait for calculations? Yeah, we're gonna do some. We'll do some next week. And it'll be kind of like this because this is the kind of the things that you get on exams. Okay. When a raceway is run through the wall from the interior to the exterior of a building, the raceway shall blank. A, be sealed with an approved material. B, be rigid metal conduit. C, have an explosion-proof seal. Or D, be rigid polyvinyl chloride. Okay. All right. So does it really have to be RMC? Does it have to be PVC? Does it literally have to have an explosion seal? So maybe on an exam, remember if you watch that video where I say reduce stress, you can weed out some obvious answers that are not the answers, right? And again, you can, all right, now you're just playing with me, O. Is that you, O? Okay. All right, so exterior of a building to the outside. Do you really fire caulk when you go from outside of your building with your service to the side of a residence? Do you fire caulk that? Oh, when you poke it outside, do you fire caulk that? Do you fire caulk it? I hope not. Now, we're not talking about going from a fire rated assembly, like from, let's say, a 2-hour rated wall penetration. That's different. That's not the question that's being asked. Okay, but I feel you. Hold on, let me give you my. Okay, So what do we need to look up here? So this is going from the interior to the exterior of a building, and it's the raceway. So this is a wiring method. This is a wiring process. It's what you're going to see in Article 300. Okay? So that's one of those things that you just get familiar with, but let's go look at the code real quick. All right, so if I was going in the index and I was going, so maybe, let's see, I'm not even sure. This is why I say the index isn't always the holy grail. I'm not even sure exactly what I would use to do this. Now, I would maybe go, let's look under Raceway. See what it says under Raceway. I mean, I know the answer, but it's not going to help you. So let's go see what's under. Well, we do have openings, but does that tell us anything? Nah. So let's go to Raceways. And it might be something in Raceways. So here's Raceways. And we're looking down and we're seeing Raceways. And this is, a bunch of different types of Raceways. Incidentally, if you didn't know where to go, that's where you go. Let's see. Supports. Nah. Ceiling. Well, ceiling under 225. Ceiling under 230.8, I see 300.7a, okay, which again is probably where we're going to be. But I see a bunch of it, and I might write each one of these down. But the question didn't have anything to do with outside branch circuits and feeders. It didn't say anything about service conductors. So again, this is an example of where if you do those flashcards, you're going to know what does 300 mean when I see it. And 300 is general requirements for wiring methods. So this is the general requirements. Remember, it didn't matter whether it was PVC, it was rigid, all of those were in the list, right? So again, it wasn't specific to feeders or branch circuits. It wasn't specific to service conductors. So it looks like 300.7 is where I want to be. But we're going to look again and see where we're at. And if there's anything else that might be beneficial in there. And I don't see anything else that's beneficial. So I'm going to go to 300.7. And I think some people already had posted that, by the way. Now there's 305. And I'm going to go to 300.7. Again, I'm looking at the bolds. Earth movement questions are always notorious on exams. Also, directional boring. Keep those in mind. They're always... Okay, so here's 300.7, raceways exposed to different temperatures. Okay, it says where portions of a raceway or sleeve are known to subjected to different temperatures. You gotta kind of know that. And where condensation is known to be a problem, as in cold storage areas of the building, or we're passing from an interior to the exterior of a building, the raceway or sleeve shall be fitted with an approved material to prevent the circulation of warm air to colder air, which creates condensation. Notice it says an explosion-proof seal shall not be required for this purpose. They're expensive for one, okay? Nobody wants to put those things in if we ain't got to put those things in. So let's kind of go back to the code, to the question. So it doesn't matter whether it's rigid. Doesn't matter whether it's PVC, both of which are raceways, by the way. Says it doesn't have to be explosion-proof, so obviously it doesn't have to be explosion. The only option is sealed with an approved material. And again, where did we get there? This question is talking about an application of an installation. Okay? A raceway installing through the wall. That is going to be, when you hear those type of things, that's underground. Installations underground, 300.5. That's the depth of cover. That's an installation requirement. It's talking about depth of cover. Your mind needs to flow to 300 for that. Okay? So 225 might give you the same answer. 230, because it's ceiling, might give you the same answer. But the accurate answer is really under 300. Now, the beautiful thing is, when you go back and look at all these and you're going through 225 and everything, you get a flavor for what's in there that you'll always retain. Okay? But the real answer, let's go back to the question. And it's 300.78. That is the more accurate answer. Although, sealing raceways are required for services, required for interior to exterior for feeders, marine circuits, as it penetrates. If there's that issue of temperature changes and can cause condensation and things like that, or moisture intrusion, there you go. But just remember, this was about a process of going from interior to exterior. Okay? And that's going to be something you'll see under 300. All right? Boy, a lot of questions tonight. Now, this is an example of one that if you had it on exam, as you get used to the flashcards, and this is one of the ones, and remember what I say in the video. Go watch that stress relief video or podcast. Go listen to it. You are not going to be able to pass an exam. Let me make that clear to everybody. You are not going to pass an exam by having to look up every question. You will fail. You are not going to pass. There's not enough time. Not enough time in the actual exam. You're going to run out. Okay? So, what do? You have to have a certain amount of questions that you just know. And as you study with a purpose, you look up the index, you look up the questions, you dissect them, just like we're doing now, you can't help but get it better. So people say, Paul, I've got to have it done in 2 minutes. Those people that are listening, and if an educator says that, you need to run from the educator. They are not worth it. Don't waste your money on their program. They're going to mislead you. You do not time yourself until you get to the last week or two. Then you can start, because you need to build a foundation of knowledge. You need to dissect questions. You need to go through your course material. You need to read it. All these things will naturally start making you better in the code. Ask any of our fast track students. Ask anybody that's successful. Yeah, you might go cram on a weekend and get lucky. But are you going to retain it? And then you still have to call somebody all the time when you have a code question? Or do you really want to learn? That's what we do here on Wednesday nights. We take our time and we dissect it. Now, there's going to be a certain number of questions that you're just going to know just like that. That's great, because that's the one that's going to help you build that bank of time on an exam. The more you answer that you just know, then you're going to build that extra time. Now, in this case, we're still studying for an exam, right? So, I don't want anybody just answering it and not looking it up. We want to look it up, okay? So, there's a couple ways you can find this one. You could probably find it in 500. You could probably find it in 502, because remember we said earlier, 501 is class 1, 502 is class 2, 503 is class 3. So, there's a couple areas. Now, I wouldn't go to 510, okay? So, it's not where I'd go, and now O is just being funny. O has a tendency to do that. So, in this case here, we need to know what class 1 is. So, we could find it in a couple locations. In our case, I would probably, if I practiced, I know that it would be 502. And I'd go to 502. Okay? But let's say I didn't. Could I find the answer in 500, which is a general synopsis of all the hazardous locations? I don't know. Let's go see. So I'm in the code. Make sure that I'm in the code. Yes. Okay. So going in, and I go to 500, and you'll see all of the applications here, and it gives you the scope, 501 through 4. And again, it tells you it covers everything, right? But if you go down and you look, that you'll actually start to see, here's class 1. And you see that that's the gases and whatnot. And then you see class 2, which tells you that it's combustible dust. So you could find it that way. Or you could go to 502. And when you get here, then you're thinking, okay, combustible dust. Right there. Okay? So, multiple ways to find this one. Okay? where could you have gone in the index? Well, if I didn't know, I could have gone to, remember what we did earlier so that we could learn? We learned that I could go to class, or I could just go to hazardous location because that's where they're all at. So now I'm going to go to hazardous location. And since it was class 2, I'm going to go look until I see, here's class 2. And let's see, well, there you go. So it says also see 502. Okay. All right, so I could go look up 502. And let's see here. Has this right here, 500. Here is class 2, which is sending me to hazardous location. Okay, so again, you would have found the articles here, and you could have gone wherever you need. Now, interesting enough, let's see here. Here's hazardous location 2, and let's see here. Remember when I said I like to play around in it? I want to look under C real quick, just for craps and giggles. And C is this combustible dust. So if you already knew it was combustible dust, but you didn't know the article, here you can look under combustible dust and it tells you that it's 502. Okay? So different ways to look through the index and be able to find things. So again, I could have looked up each one of these and ultimately would have ended up at combustible dust. So just different ways to do it. So we'll answer it. And there you go. Look at here. They use this method, the 500.5C, the first way we did it. But don't you see that you could have gotten there other ways? You could have gone to 502 and it would have answered this question. Okay? That's the thing about the index. It's not the Holy Grail. And there's usually in the code, as you saw with the ceiling, there's multiple ways to skin the cat. All right? All right, we'll end on this one tonight and see how you do on this one. Let's everybody try to participate on this one and see what you get. Don't stay quiet. I'm just teasing you, O. You know I can't help but tease you. Hold on. What am I supposed to do? Just teasing you, buddy. All right. Given a size 14 AWG branch circuit conductor protected by a 15 ampere rated circuit breaker is to supply 3 20 amp rated duplex receptacles. This branch circuit blank. Okay, so it says would be in compliance with the NEC if the wire was sized to 12. Okay. Is in compliance with the NEC. Okay. Is not in compliance with the NEC because the receptacle outlets have a 20 amp ampere rating. Ooh, this is an interesting one. And 4 would be in compliance with the NEC if the circuit breaker was rated 20 ampere. Okay, really good question. And it's kind of a spin on using the tables that are in 210, so kind of a spin on how they do it. So in this case, I love to dissect these questions because we know that in 240.4D, it says a 14 gauge has to be protected by a 15 amp device. So we know that part. That's a learning thing. We got that. Okay. The next thing we say, does it really matter that it's 3 receptacles? No, because the code doesn't tell us how many, except we're not talking commercial. Nothing was said it was commercial at 180 VA per strap. Nothing was said that. There's no limit to the number of receptacles we can put on a branch circuit in a dwelling. So nobody actually said it was a dwelling, but you typically wouldn't use 14 gauge in a commercial because that's just a little knowledge-based thing. So I'm looking at it going, okay. So would be in compliance if the wire was 12. Wait a minute. It's a 15 amp breaker. That's not going to work. Okay. The next one is in compliance with the NEC, and you're thinking, the 15 amp device, an overcurrent device is 15 amps. That device is 20. Okay, the device is 20. It might be okay. We're gonna have to look at it and see. We're gonna look it up in the code. Okay. Now I see a code reference, but I don't see an answer, mister. So we're gonna look at the next one. So now it says it's not compliant to the code because the receptacle outlet had a 20 amp rating. Okay. So it's this 20. It's a 15 amp circuit with a 20 amp rating. Okay. And of course, would be in compliance with NEC if the breaker was rated 20 amperes. All right, look. The what ifs don't matter on an exam, guys. Would be compliant. First thing I do is throw out the would be's. Pointless in this question. The question is it compliant or is it not compliant? That's the question. So let's go to the code. I have no idea why that button was going because I don't have my headphones on tonight, guys. So I have no idea what was going on with that my buttons there. I decided not to do the headphones tonight. Okay. So we know that we're dealing with the question is talking about a branch circuit. So we know it's 210. So we're going into this is a classic fast tracks question though, by the way. All right, so let's go to 210, and I'll show you how to look it up in the index if you didn't know. But let's go down and look in here. Okay, so first things first, 210.19, conductors and ampacity. The general branch circuit shall have an ampacity of not less than the maximum load to be served. Conductors shall be sized to carry not less than the larger of 210.19A1A or B. A's being 100% of the non-continuous, 125 of continuous, or has to carry the actual load after adjustment and corrections. Wasn't the question. I do cover that in D-Rating Demystified, so hopefully you go watch that video. All right, so branch circuits with more than one receptacle, which incidentally is a duplex, is more than one receptacle, by the way. Conductors of branch circuits supplying more than one receptacle for cord and plug connected portable load shall have an ampacity not less than the rating of the branch circuit. So it can have a rating less than, 15 amps. First thing we got. All right. Now, let's move on. So the next one we look at is outlets and devices. And we have choices. We have receptacles. Single receptacles on an individual branch circuit. That is not what we're talking about. Now we're talking about cord and plug connected loads. And then, of course, we have receptacle ratings. That's going to take us down to these tables. Now, check this out. We get another one here. Yeah. Okay, hold on. Right here. Notice in this table here that the receptacle ratings, and ours was a what? 20 amp? What do you think? 20 amp rating? What do you think? What is this? 15 or 20 amp circuit, 15 amp device. A 20 amp circuit can have a 20 amp device. A 15 amp circuit is not over 15, the receptacle rating. But I can use a 15 on a 20 amp circuit. Okay? So I can use a 15, the device, but our device was rated 20, which I can use on a 20, but not on a 15. So now, all that being said, let's go back to the question. Oh, why did it do this? Oh, sorry about that. Okay, so back to our question. Get rid of so let's kind of look at it. Now, I told you to get rid of the would-be's so that we can focus on the question. Now, let's focus first on the question, and then we'll look at that. But first, is it compliant? Okay, it's a 15 amp rated breaker. You can't put a 20 amp device on a 15 amp breaker. So it would be not compliant right now. Okay? Would it be compliant if we used a 12? That doesn't change the breaker. That's why it doesn't matter. Would it be compliant if the circuit breaker was rated 20? Well, no, because the 14 gauge is only rated for 15. So that wouldn't be it. So the only answer here can be that it is not compliant because the receptacle has a rating of 20 amperes. I don't know why I keep doing this, guys. Sorry about that. So let's do this and see what we got. There you go. 210.24. Okay. Now, you can get this there in many ways. Let's go back to the code to look at 210.24 because we were looking at the table, and that's how I got my answer. But let's look at their code reference. And that's what I say. Get you a good set of code questions with the answers because you can use the answer to cross-reference it and look back and try to see where the question was. Now, we answered this based on the tables. But let's look at table 210.24 and see what we got. There's 210.21. And here's 210.24, the summary. And then the summary basically pulls all this together. So you can use table 210.21 or you can use this table. And this is actually a summary, pretty neat little table, by the way, of all of this information here. It all pulls it together. Pretty neat table. So the circuit is rated 15. The conductors are going to be 14. The overcurrent device has to be 15, and the receptacle rating is 15. Notice that it's a 20 rated circuit. The overcurrent's 20. Notice that receptacles can be 15 or 20. Okay? So all of this is just a compilation of everything that's covered back here. Okay? And all these requirements here. So again, that's just kind of one way to look over the question and give you ways to look at it. But I tell you right off the bat, you won't see any question on an exam that is going to say would be in compliance if this. Okay, so rest assured, this was only there to try to confuse you. You're not going to see that on an exam that way. It would be in compliance. That would be a crappy question. Crappy question. And I serve on many panels that write exam questions. Never would I write a question that way. But when it comes to prepping for an exam, it's a good question because you really need to stop and look at the answers. So I tell people all the time, what do I do when I study for a purpose? Just what we just did. Take your time. You're not in a race. You're here to relearn it, okay? Take your time. Look at all the probabilities. Take the question, dissect it, look it up in the code, and you might be surprised you'll find multiple ways to get an answer. And actually, I'm going to confess something. This whole concept that I came up with many years ago was to serve one purpose. And ready? I'm going to blow this tonight. My only purpose is, the only way to ever get good at the National Electrical Code is repetition. Doing it over and over and over. There's no tricks. There's no shortcuts. Even though we might say something like, well, if you learn that dot 30 in all the wiring methods is securing and supporting, so if you always remember if it's a securing and supporting question that dot 30 or section 30 of a specific code article for a wiring method has to do with securing and supporting, that's a trick. It's not a trick. Okay? It's just something that you retain. Okay? Like use is permitted is a dot 10. Use is not permitted is dot 12. All of those type of things are just techniques, but you get it from repetition, not from some weekend crash course where somebody takes $400 and $500 of your money. You sit in there for 8 hours each day. By the time you're at the end of the first day, your head is doing this. And what happens is you start thinking, I just spent $400. In many cases, you got to travel out of town to do it. Now you got hotel bills. And now you're thinking, oh crap, I'm not ready. And you've already spent your money. There's a reason why I say give yourself 60 or 90 days. I prefer the 90. There's why you don't need to have a program longer than 365 days because you're going to pass your exam way before then. That's what the Fast Tracks is all about. And if you follow those that are in the program, Josh, if you follow the program, ask Brian, he was in the program. If you follow the program all the way through, there is literally no way you cannot fail. Okay? Excuse me, did I say that right? There is no way that you cannot pass. Must be a long night, dude. You know what? I ain't perfect. But there you go. So hopefully y'all got something out of it tonight. Again, I try to make it fun. I don't have to wear my tie and my suit when I do this with you folks, and I appreciate that you allow me to be that way. When I teach around the country, I have to wear suits and ties and act totally different. But I'm allowed to just sit with you. When I started this concept, I wanted to be casual, that you can ask me questions. Bring your questions. If you're working in the program, the fast tracks, or you're working on online questions, bring them to me. Email them to me at info at masterthenec.com. And you can email me, and I will go over them with you. Okay? All right. So that's it for tonight. Let me go back to the main screen. We did it for a couple hours here tonight. Kind of dissected it. Let me know if you like the slow approach or you want me to just go faster. I don't know. I usually like to get the different, feedback on that. Hold on for a second. There we go. I lost that for a second. Let me know what you think on this. And again, next week we'll do some calculations. Maybe still look at some exam prep stuff, but we'll do some calcs. Encourage you, if you're studying, go over into my playlists on the YouTube channel and be sure to go to calculations folder and watch those videos. Listen to those podcasts. You're going to get it. I do ranges, dryers. I do single-family dwellings, multifamily dwellings. I do optional and standard calculations. A bunch of different stuff over there. All of that stuff's to help you. And if you're in our Fast Tracks program, be diligent. Stay focused. Read the material. If you'd rather have play to you while you read it, do it. Okay? But you have all those options in the Fast Tracks program. Josh, for example, if you haven't watched the video, the demo of how to get the best out of the Fast Tracks program, make sure you watch that video. It is available on the same page that you bought the program on. It says demo. Click it and watch that video. It gives you a better understanding on how to utilize the program. Okay? There you go. Let's see. Let me catch up on a couple questions, and then we'll kind of go tonight. If you have any questions, feel free to ask. Mr. T, I'm a God. Thank you. Sometimes I feel like I am nowhere near that, my friend, but I appreciate you. I just struggle with trying to bring these things to a down-to-earth level. See, I don't want to talk down. I want to talk with you. I want to teach code with you. And again, I don't want to get on there and act like I'm holier than thou. I want to be with you. I want to take these slow. I know the answers, but I want to look it up. I'm always wanting to learn too. Okay. So, I love learning. It's a whole focus of why I do what I do. I never know it all. Definitely, mister, get some rest. Get up in the morning. Confidence. You're going to nail it, my friend. You got this. You got it. I want to expect you to come back. And if you don't, you come back and you happen to fall short, don't get down. You will get it. Just focus. Look for areas where you maybe didn't work hard enough. Okay. But right now you're done. Go relax and get ready to nail that sucker in the morning. Get in there, take a deep breath. And here's one quick tip for you. If the first 2 or 3 questions you get, you don't know, and you're like, uh-oh, that's okay. Make sure you listen to my podcast about the waves. Mark it, electronically mark it, and go on to the next one. Do not dwell on it. Don't dwell on it. Keep moving on. Keep moving on. You'll be fine. Do it in waves. Build you some time. Okay? All right. Anyway, whatever. What do we got here? I don't know if there's anybody from Florida, Mark, in here tonight. I'm sure there's some maybe listening. Some of them are very quiet, and a lot of people watch and don't say anything. I don't know why. I would always think that I'm approachable for you to type questions. Of course, I have my trolls that do that anyway. Also, I should mention again, if you're interested in the light, donations, got our name on it. Okay, we're giving those. And the screwdrivers. Whoop, whoop. Neat screwdriver. The tips come out the end of it. You've probably seen them before, promotional. The tips come out the end of it. And they work on glasses really well. And it's magnetic tip, and they're metal, it's aluminum. And the tip goes in it. And it's got flats and Phillips and everything in it. Okay. And that's for donating. And you can donate on our website if you want to give back. If you got something out of our videos or podcasts and you want a way to say thank you. People have asked us and they've donated for years, and I never could give anything in return other than thank you. But now we have some things that we can send you in return. All right, so check those out, masterthenec.com, just like you see right here at the bottom of the screen. Or you could donate here under the super chat as well. Anyway, so if you donated, make sure that if you did donate, that you send me your full address, okay? Always send your address to my email address, info@masterthenec.com, and I will see that gets sent out to you. They're in stock. We have them in now, so we have them. We'll send them to you. We'll be able to give that to you and for your donation, okay? But if you donate or you do it online, you still have to send us your address, okay? Question real quick before we go. Paul, can you give me the difference between a linear load and a nonlinear load? Sure. So we talk about nonlinear loads. So a linear load is a load that goes through a sinusoidal wave path. It's up and down. It's very predictable, constant, like typically a motor is going to be a linear load. A nonlinear load is a load that actually, and I'm paraphrasing it, a nonlinear load is a load that actually breaks the waveform. It's erratic, and it does not have a pure linear motion. So again, harmonics, triplet harmonics, fluorescence, computers who take a waveform and it literally chops it up because it's on and off, on and off, on and off, on and off, on and off. When it does that, it's hard for neutral. And again, when you ask about linear loads and nonlinear loads, you're really asking about what does it do to the neutral? Because other than that, it really makes no difference, right? So what it does is dealing with nonlinear loads is that it breaks up the waveform. And so for neutrals to carry the imbalanced load or the unbalance between the phases, it has to be a linear load. So when it goes to nonlinear loads, it actually causes the waveforms to not be able to cancel out, especially with three-phase, because you've got all these phases and there's not a cancellation. And so the neutral can see sometimes 2 times the amount of current that's on any one phase. And that means that the neutral can be overloaded. And so, again, it's dealing with harmonics that are dealing with a frequency. There's ways to clear it. You can use a K-factor transformer. You can use inline filtration. You can oversize neutrals, which, again, you're not getting rid of anything, but you're just oversizing the neutral because there's going to be more current than expected on the neutral, right? So, again, that's the big difference between linear loads and nonlinear loads. Probably can Google it and get even more detail with that. But, again, it's not predictable waveform. It's erratic, and there's a lot of things that do that. Variable frequency drives do it. Fluorescent electronic ballasts do it. Computers do it. Anything that has solid state that switches on and off, all those type of things are going to create an issue with dealing with non-linear type of loads. Think of linear as a nice, even, balanced waveform. Non-linear is a chopped up mess. Okay. Let's see what other question. Hopefully that answered the question. WE as basic as I can give it. So O says, Paul, why is it okay to share neutrals on a 3-phase, but not on a single phase? I'm not sure I know what you mean, O, because we share on a single phase all the time. A 2-pole breaker in a 120, 240 volt panel, that's a single phase system. And a 2-pole breaker with a black and a red sharing a neutral, that is single phase. Okay? So I'm not sure what you mean by that. In a 3-phase, it's the exact same way. You basically have 3 120 volt phases, and it's sharing a neutral. If it's single phase or 3-phase, you can still have multi-wire branch circuits, right, that share a neutral. Doesn't really matter that it's 3-phase or single phase. Doesn't really matter. You just got to be careful because of the breakers. They got to be 3-pole breakers or 2-pole breakers or single poles with identified handle ties so that when you turn one off, they all get cut off. Obviously, on a multi-wire branch circuit like that, it's sharing a neutral. You don't want to turn one off and you think there's no current traveling, and then all of a sudden you get a hold of that neutral, and guess what? It's got return current from the other phase, right? So that's why you want it to be either a 2-pole or 3-pole or a single pole with identified handle ties, okay? Yeah, so you can have a laundry. Let's say I had a laundry and I had 3 separate washing machines that are 125-volt rated NEMO receptacles, but it's 120-volt loads. Yeah. So I could have a 3-pole breaker. I have a 120-208, let's say. I have a 3-pole breaker, and I've got 3 separate 120-volt branch circuits that are sharing a neutral. And the cancellation effect is going to be able to allow me to share that neutral. As long as we're not dealing with harmonics, triplet harmonics, or nonlinear loads. And those washer machines typically would not be nonlinear loads. Okay. I do have a box fill video. It is available over on our YouTube channel. Just go into calculations, the playlist for calculations, and you'll see one in there for box fill. And I will do that again one Wednesday night we'll do, because I kind of think that's calculations too. So if everybody wants that, and you feel, because that is on exams, I can tell you. We could do that next week too if you want to do some box fill. The question is, do you think studying cover to cover is the best option? Okay, this is a great question. No. Because remember, my golden rule is you need to study with a purpose. If you just flip that code book open and try to read it from cover to cover, you're not going to retain a daggone bit of it. Because you're not studying with a purpose. The way people retain, let me give you an example. When you go and wire something or you do something, okay? When you do it, you remember how to do it because you did it. If I'm just reading the code, I can't put any context to it. But if I'm using questions or exam questions and I'm opening the code book and I'm studying the code based on those type of things, then I have a better chance of retaining it. So I don't believe people read it from the cover. I have never sat and read the NEC from the front to the back. Now, I've looked up enough code stuff over the years that I feel like I've read it from cover to cover. But there's going to be a lot of stuff in there that you're going to read that is not going to be beneficial for an exam. And you're not going to comprehend it when you read it because you might have never done it before. And exams are going to be designed. Now, people that write exams, like I've written exams for states, we're looking for specific things. Usually exam questions online or in our programs are all going to be tailored around those type of things that you're looking for. So no, I don't recommend you starting at the very first of the page and do it. Now, when I teach code, like in my 2020 review, I do start at the beginning and go to the end because I allow you to pick wherever you want to jump in and learn the code, okay? But that's not for exam prep. That means you already have your license and you're just trying to learn the code better. For an exam, study with a purpose. Use good code questions. Go in with a reason. Go in with the purpose, okay, to look up something. Let me see here. Why is 208 volts don't have a neutral? Well, because it's 3-phase. So first things first. 208 volt 3-phase, for example, is an A, B, and a C. Then again, it's the alternating lagging waveforms. So at any given time, AC current is changing directions. So it starts on one leg, starts on the next, starts another. It's all based on the 3 different phases and how it operates, okay? So 3-phase is kind of like, here's how I explain it, of a motor for 3-phase, okay? With the windings. You have a winding where the magnetic field gets it started. But if you didn't have another one out of phase, then 180 degrees out, 120 out of phase, then in a 3-phase, then it wouldn't get it started to push it going. Keeps it pushing it. So that's the 3-phase. So no different than when we have 240. Okay, we have a 240. We can have a 240 volt without a neutral. We can have a 208 without a neutral. We can have a 208 circuit with a neutral. Okay, very common. All right, so not 100% sure the question, but again, 208s that I deal with, unless it's 208 load to a motor or something that doesn't have a neutral, then it doesn't need a neutral because it's balanced. If it wasn't balanced, then you have to have a way for imbalance to get back, and that's why you need a neutral. So most of the time for motors that are 208 with no neutral, it's because the way the windings are, it's a balanced load. Okay? I don't know if that's a easy way to answer that question for you. Power returns on 208 the same way it does on 240. Everything changes directions. 60 hertz. Okay? Okay? Changing directions multiple times. That's alternating current. So it's going one way, it's going the other way, going the other way, going the other way, going the other way, back and forth, back and forth, back and forth. Okay? Now remember, voltage and current and all that relative, it's not like we hear people talk about the flow of water. It's not. Okay? It's the movement of the electrons. So the movement of the electrons on and off in different directions. Basically, think of it this way. In 208 or even 240, when it's moving this way, the pressure, the voltage pressure, it's moving this way. The electrons move. Then it changes direction. They move. Change direction. They move. Move quickly. Woo! Back and forth. And all those electrons get all happy. That's what generates current. That's how electricity is. It's not flowing. The same electrons that are in this piece of wire that you might have are the same electrons that are in there when that wire was first made. Okay? Same there. Nothing changes. All we're doing is applying voltage, which is pressure, causes those electrons to move. When you have differences of potential, you have current flow. That's kind of how it works. I don't have a dwelling unit. I have not seen any 120 208s, but if it is a 120 208 dwelling unit, well, you're talking about maybe a unit inside of a multifamily building. Then you've got 208, which actually works just like 240. It's just all the appliances will be based on 208. Okay? The 120 is for the single receptacles. The 208 is for any of those appliances that are going to be rated at 208. Okay? Works no different. Okay? Just remember, I can have a 240 volt load, single phase, it doesn't need a neutral. I could have a 208 load that doesn't need a neutral. Okay? Where do you use 208 and 440? Okay, well, typically we're looking at, so it wouldn't be 440, it'd be 480. And 208, so your voltages. So in the code, you look for standard voltages, right? The standard allowances. And it's going to tell you that it's 120, the nominal, we call it nominals. 120, 240, 208, 277, 480. All of those, for example, are nominals. Now, when we're dealing with motors, we deal with the value that's written on the motor or whatever in the exam question, right? Whatever they give you in the question, you use what they give you. But that's values that are based on motor ratings. Whereas the nominal rating, so where would I use the 480? I think you mean instead of 440. 480 is very common in switchgear in large buildings. That'll step it down later. So they start with a higher voltage and they step it down with a transformer, step down transformer. There's motors that are 480 volt motors. There's 208 volt motors in industrial facilities. Not so much dwellings and residential do we have too much, although they do make appliances that are 208, which is probably what O is alluding to. So again, if I'm going to, he's saying an FAU, which is an air conditioning unit, it has no neutral because it's the motor that's in there that's driving the air conditioning unit is a motor that's balanced. So that's why it doesn't have a neutral. It's 208. There's no neutral loads. So the code's kind of funny. Because the code says you have to bring a neutral or grounding conductor to the service. Once you get downstream, I don't have to have a neutral unless I need a neutral, right? If I need a neutral, then I install one. I'm not required to have one, but if I have neutral loads, I got to have one, obviously. Okay, but to the service it's required, downstream not required. Okay, so but again, so Ramiro, most of the places, those are going to be appliances that'll be 208. Again, probably commercial applications to that type of things. Probably where you're going to get the most. Okay. 13.8 volt, I wouldn't expect you to see that on exam. That's typically substation stuff. That is medium voltage. I don't teach medium voltage, so I don't get into that. You look that up in the code just like you would anything else, but I don't deal in that. But that's typically substation. Large commercial buildings that want to bring in direct lines from the utility or have their own site substation will start at 13.8 because you can transmit that voltage higher for long distance. Thank you, Tesla. For long distance, and then you can drop it down to lower voltages without any real losses. So that's why 13.8 is very popular. Things for, somewhere around 13.8 is very popular for substations, and big facilities like Uncle Wire have our own substation. And so we'll take the voltages coming in from the utility at higher voltages like 13,008 or whatever it would be. And then we do what? We step it down. So we have less losses that way. Okay. But again, you're not going to see much 13.8 in anything. And I'm assuming you mean 13.8 as in 13,800 volts. I'm assuming that's what you dealing with. Okay. It might be what you work with, but I can't imagine a National Electrical Code exam being based a whole lot of questions on 13.8. Okay. And that's medium voltage. Code does deal in medium voltage. Wire is 311. And then you have over 1,000 volts, which again is going to kick into all the rules for 13.8. I just don't dedicate any classes to medium voltage. There's not enough questions on an exam in medium voltage, if not any. And I wrote plenty of exams, and I never wrote a question for medium voltage on an exam. Some states might, but most of them that I'm dealing with never did. And I don't teach medium voltage anyway. Sorry. I hate to be a buzzkill, but I don't. Okay. Let's see here. Yes, the FAU was 208 and the stove was 240 with the neutral. So without neutral made it a 208 single phase. Again, I'd have to look at it. It sounds like some people might have gotten some things messed up, but again, you can have a Delta system, for example, and you can get 208, 240, and 120 in a panel. So that might have been what they had. But it seems really weird that the 208 would have been fed from the dwelling unit. Now, I think that it might have been 120, 240 in the dwelling unit, but back in the service equipment, you might have had the ability to have 208 to feed air conditioning, rooftop units, things like that. Sounds more plausible. But you can get a Delta system high leg where you can get 240, you can get 208, okay? Not much, 208's not that usable, and it's typically not going to be in the method that we're describing here, and it doesn't have much real use for it. But something seems a little wonky about the way that question is on the configuration, okay? But the key thing to remember is you need a neutral when you have neutral loads. If you don't have neutral loads, you don't need the neutral. Now, be careful because the piece of equipment might require you to take a neutral. That's part of the equipment. And it might even be part of the engineering specifications as well, so keep that in mind too. All right? Let's see here. Jacob, yep, 480 is very common for us. Absolutely. Motors, very common 480. Obviously, the higher the amps or higher the voltage, then again, lower the current. Let's see here. What other question do we have? Don't you have any electrical program that could allow me to have certificates? If you have, I will take how many months? And none of our programs are designed for you to do anything other than prepare you for an exam. Many people that are in our programs are doing it because they want to gain a greater knowledge. For example, we have the residential, commercial, add the grounding and bonding. We have the industrial wiring. All of those type of programs, they're not certification courses, right? They're to give you more knowledge. The only certification program that we have is the CMECP program, and that is to teach you to understand the code better, and that's to become a CMECP. It's not going to be for anything else. It's not going to give you credits for anything. I decided not to go that path because every state was different, and I did not have the time or the desire to go to every state and have my courses approved for pre-licensing credits. It's not worth my time. Most people are in an apprenticeship program or in a journeyman or in a apprenticeship program or some kind of training program. So they're going to get that anyway. And most states, you don't even have to do that. You just have to put your time in. And if you have to put your time in working for a master electrician, then at that point, my course is just going to make you better at the code and help you pass exams. Okay? But I have a lot of students that got our bundle, our 2020 bundle, and that 2020 bundle we have is a deal because it gives you access to all the 2020 courses that we have, and you get 2 years worth of access. And you get to learn more about residential, really in-depth, commercial, a lot of good stuff in commercial, tips and tricks and things, really test your knowledge, grounding and bonding and all that kind of stuff, but it's not for any certification, okay? Yeah, high leg is going to be B phase. Now, ironically enough, high phase out that the utility brings in through the meter might not be B phase, but when it comes into the panel, the high legs do have to be on the B phase. Absolutely right. Let's see, question. EE says, how can you determine that you encounter harmonics or nonlinear loads? Do you use a meter to show the sine wave? All right, so there is meters that can detect that. Interesting. I use 2 different types of meters, and I was going to do a video on that, but our attorneys suggested I didn't, and I'm old school, so as a way that I can do it, and use 2 different meters and clamp-on meters. I have one that's a true RMS and one that's not a true RMS. So I have a fluke, and I have my aims that you probably see me demo online on a demo. And you click that on circuits, and there's a calculation that you do between them, and you can tell if you have a certain level of harmonics. Or you can get a total harmonic distortion meter, and you can get it that way. But what I can guarantee you is that the engineer who's designing the system should know if harmonics exist, because if there's a lot of electronics in there, a lot of computer systems, a lot of electronic ballast fluorescent lighting systems in there, a lot of variable frequency drives, computers for office buildings, all of those things create, are all examples of nonlinear loads. And they're going to create harmonics. But if you really want to know the level of your harmonics, then you have to give a total harmonic distortion meter, and you can actually connect it and actually take the readings, and you can get those readings. Okay, so they are available, and they're not cheap. So I have a method that I can use, but it's only to tell somebody they have harmonics. If I want to be really accurate, then I have to get a meter that'll read that. Are you allowed to write anything like formulas, examples in your code book? Jacob, it really depends on the state you're in. So what I recommend you doing is if PSI is the exam group that administers your exam in your state, and I don't know which state you're in, tell me which state you're in, and I'll try to look that up for you. But in Texas, you can. And for example, many people have seen on my Master the NEC exam prep forum, I posted about 6 or 7 pages of formulas that you can cut and copy and print and write them in your code book, and do it at the very front of the book where you have the code panel members. You'll see my name in there on code panel 5 and code panel 17. But other than that, there's a lot of open space in there. So if you're in Texas, you absolutely can write your formulas in your code book, 100%. And writing them in the front is the best place because there's a lot of space there. So you're in Texas, I don't even have to look it up. You are able to do it. Write them in your book. And again, if you want to see all the formulas, join my Master the NEC Exam Prep Facebook page. And on there, I've posted it and you can see all of it. And I give you a bunch of formulas that you can copy and put in front of you. You can even put them on the same page as I put them on. I did that during exam prep one time when I was doing the live shows and I was doing the exam preps. My lights again. Okay. All right. What else do we got here? I said I was going to go about an hour ago, but you got questions? I want to answer questions the best I can for you. Let's see here. Those certificates are usually full-time and 1,200 hours. Yeah, so states are different. Some states, it's different, 1,200 hours. Some states, it's 4,000 hours. Some states, it's 600 hours. You could use a vocational school. Some people, if you already have an engineering degree, you can already qualify because you got, Lord knows, plenty of time involved in schooling. So again, each state's different. If you want to know what's required in your state, I will tell you where you can go. Let me go back to a browser real quick. And let's see here. Let me show you some stuff in case I haven't done this with you guys yet. Let's go. So go to electricianschool.edu.org. It's called electricianschool.edu.org. Okay. And let me get rid of this. Y'all don't need to see this real quick. Let me turn that off. So what it looks like is this is what it actually looks like. So it's electricianschool.edu.org. I know you can't see, but a part of that. And then you'll notice on here where it's got a bunch of information, state by state licensing at a glance. So what you want to do is just scroll down, and then here's your state. So I think somebody said theirs was Tennessee. So you'll click on Tennessee, and here's Tennessee. So Tennessee, apprentices don't have to be licensed. So electricians license, it says must pass a law, which I don't teach business law for your state. It's usually just a simple pamphlet. I don't teach it. And electrical exam. It says applicant holding a contractor's license are exempt from the exam. Requirements may vary. Generally require 8,000 hours of apprenticeship plus 500 classroom hours. Okay. Now, here's a link to go to the licensing board for Tennessee, and you get to get deeper into it and look all of it. But Tennessee's, for an example, where they want to make sure that you have apprenticeship plus classroom hours. Not online, but literally classroom. Okay. Okay. So now, if you're already an electrical contractor for some reason, then you can be exempt from that, all right, from exam. Okay. And there's the Board of Insurance that I clicked on there. And you can get your licensing and regulations right here. And obtaining a license and everything, lookups, licensing requirements. And let's see here, I could go down. And let's see here. Is home inspectors, contractors. And here's the contractors and residential, the continuing ed. And there's just a bunch type of licenses here. And there you go, licensed contractor. And let's see, type of licenses. Here you go. Limited license for electricians. All right, so here's the application. Here's the licensing. Here are the rules, regulations. Here's the laws, which is usually all you need for the exam anyway. So people ask me, Paul, don't you teach the business law? No, usually they'll give you all that stuff that's necessary for it. Okay? But anyway, there's everything that's there. There's the rules, regulations. That'll tell you the hours, the continue, all the stuff that you need. The laws, I'll click on the laws, and here's the laws. All right there. And all you have to do is print it out, and they'll let you take this into the exam. Okay? So anyway, just a way to kind of some good information. Let's go back to... But just make sure you remember that website. It'll help you. It is, again, electricianschool.edu.org. Okay. Hopefully that helped you out there with that. So that's Tennessee there. Is there an easy way to remember whether you're able to round up to the next size overcurrent device or you have to round down? Okay, so generally, anytime you're dealing with a feeder application, let's say you had motors and you're doing feeders and you're doing a short circuit ground fault, you're gonna round down. You're not gonna round up. Typically, anywhere else when it comes to overcurrent devices, anywhere else you want to round up. The only other place that you can remember, if I had to tell you some things to remember, on feeders, for like multiple feeders, for multiple motors, the overcurrent device, which is also the short circuit ground fault protection, you round down. Secondary conductors on transformers. For example, if I have a secondary transformer and I'm going into, let's say, I could not have a 400 amp device in a panel that I'm going from a transformer secondary conductors to under 240.21 C. So I'm going over to it. If it's a 400 amp device, I cannot use 500 kc mil because it's only good for 380 amps. So I can't round up. I can't go to the next size. I have to protect it at its value. So I'd have to go up bigger on the conductor. Okay. So I can't do next size up rules. In other words, I can't size a conductor for 380 amps. Oh, a breaker doesn't correspond. I can round up to the 400. Doesn't work with secondary conductors dealing with secondary conductors for transformers. So feeders, doesn't work. Secondary conductors for transformers, doesn't work. So rule of thumbs, anywhere else, typically when it comes to overcurrent devices, you can round up. Now, one thing to remember, if you want to, not a shortcut, but if you really, really want to, other than the ones I just told you, which is the ones that you really need to remember, other than that, the only thing you really need to remember is 240.4. And so if you go to 240.4, I will show you right here. So this is the most important one right here. Overcurrent devices, 800 amps. You can go to the next size up as long as none of these apply. For example, on a branch circuit to a receptacle, if there's more than one receptacle, and a duplex is more than one receptacle, by the way, then I could not do the next size up rule. If it's over 800 amps, I can't use the next size up rule. I can protect it at its ampacity. Okay? So, again, this is what I tell people right here. Other than for secondary conductors where you can't use the next size up rule for transformers and feeder applications in 430.24, I believe, which is going to talk about that and conductors and everything, then you're not going to do the next size. You know what? It's not that one. Hold on. Now that I've said that, I need to clarify. Hold on. It is actually, I think, yeah, okay, so here's your 24. That's for your conductor sizes. Actually, it is, hold on here. So here's your one for those, and hold on, let's go down to, okay, we have servo motors, okay, and you have multiple loads, and so you're not going to do it for the dealing with the feeder in the application. And again, where is that? Make sure I'm still on code. Yes, I am on code. All right, so notice that when you're here, you have small values. Let's see here. I want to get the one that I need, the better one. Okay, hold on here. Hold on here. Pop it up. Oops, I went too far. Okay, so servo motors, that'd be the example there. Let's see here. Let's go to another one. Let's go here. So let's look at this one. Okay, so where this says, it says where the feeder supplies a motor load and other loads, the feeder protected device shall be rated not less than the required for the sum of the other loads plus the following. Okay, so you got the single motor, rate that 430.52. Okay, and of course, you also have 62, and we're going to look at that right here, 62. And here's where it says the feeder supplying specific fixed motors based on 430.24, which we just looked at, shall be protected by a protected device and a rating and setting not greater than the larger rating of the setting of the branch circuit, short circuit, ground fault protection for any motor supplied by the feeder. Okay? Based on the maximum permitted value for that specific type of protected device. Just a fancy way of saying the first motor is done at 430.52, short circuit and ground fault protection. And then you take what? The full load current of all the other motors in the group. Okay? And we cover this in motors. But the key here is that you cannot, it says that it can't be greater than. Right here, not greater than. So you can't use the next size up rule because it's telling you you can't do it. Now, for 430.52, for a single motor, for example, right here, we have the allowances that allow us to do this. Okay? And that is right here in 52. Let me get back to the beginning of it. Right here. Okay, protected device rated. You get down here to the exceptions. And it says where the value of the branch circuit, short circuit, ground fault determined in 430 does not correspond with the standard breaker or ratings or fuse. It says a higher size rating or possible setting can be used as long as it does not exceed the next higher size. So I can go up there. So if I had to tell you something to remember, and I was a long way of talking about motors, just remember, for feeders, for multiple motors, you can't go next size up for a breaker. Secondary conductors on a transformer, can't go next size up. Look at 240.4D. Any other case, I can go next size up if it doesn't correspond. So I don't know if there's a shortcut. And I don't know if I caused more confusion there than I needed to because I was just looking for other examples in there. But, just remember 430. If you're dealing with motors, just remember 430.62 for feeders. You can't go next size up. Transformers. Did you want me to show you where that was? So transformers, secondary conductors, while we're here, we would go to 450. Just so you know. And 450. Excuse me. Well, I don't know why I said 450. 240.21. And we're here at C, transformer secondary conductors. Okay? Now notice what it says right here. The provisions, I don't know why I kept saying D, it's B. The provisions of 240.4b shall not be permitted for transformer secondary conductors. Well, what is 240.4b? We just saw it a minute ago. That is what? That is this. I can't use an next size up for those. So if I have a transformer that's got 500 kc mil, 380 amps is what the 500 kc mil copper is good for. If I have a 400 amp rated device that it's terminating into for panel board, of course we have the panel board protection at 408.36 requirements. So if we're protecting it at 400 amperes, I can't terminate 380 amp wire onto a 400 amp device because of that rule in 240.21c. It won't allow me to do it. So general rule of thumb, don't next size up for breakers for multiple motors. Don't do it for secondary conductors on a transformer. And remember 240.4b, this is what gives you the permission to do the next size up, okay, in this application. And anywhere else in the code, it'll tell you in that code reference if you can do next size up, okay? Don't know if that helped you or confused you, but I wanted to cover all of it. So I kind of looking all through motors. There's a couple different examples there, but really your key one for the next size up rules and making those statements is 430.62, where you can't go next size up. In 240.21c, you can't go next size up. But anywhere in 240.4b, I can go next size up. Or anywhere else in the code that tells me that I'm okay to do next size up, then I can do it. So I don't know that there's a trick to it. That's just kind of got to get used to it. Also remember an exam, if your question comes and deals with over 800 amps, then you can't do the next size up. It's got to be full sized, okay? It has to be equal to or greater than whatever the ampacity value is based on your calculation, okay? So if it's 850 amps, okay, yeah, then my wire has to be good for that. Then my breaker has to be that or greater, So, and if it's greater, I still got to protect my wire. So that means my wire might have to be bigger. So everything gets beautiful if it's 800 amps or less. Once it gets over 800 amps, kind of gets, well, I know we do have some allowances with services that allow for that based on the calculated load, but for the most part, that's pretty much a quick, off the top of my head type of scenario. Let's see. Question is Stanford Career Institute. I don't know who they are, and you'd have to see whether or not they actually give you credits that go towards licensure. So you better check with your state, because I could offer my Electrical Code Academy offers stuff that might be acceptable, but I don't actively seek that with each state, and they would have to. Okay, now if they're DECA or they're state funded, governmentally funded, then they probably do. Okay, but you need to check with them. I don't know. Just again, don't take what anybody tells you on their site. Dig in yourself and make sure you ask those tough questions. Okay. Penn Foster has an electrical program, but it doesn't qualify for any credits. It just teaches you the electrical stuff, because many states, there's some states that don't require the, Virginia, for example. Virginia had to have a certain number of hours, but it wasn't a massive amount, and you can get that in an apprenticeship program, okay? So, and some states don't have any prerequisite for schooling. Just have to learn from a master electrician, and then they'll let you sit for an exam. Every state is different. That's why that link is pretty neat little link, because electricianschool.edu.org is going to let you know what the requirements are for each state. Okay. See what I got here from catching up on my questions. Paul, are you alive every Wednesday night? I'm usually every Wednesday night. Sometimes things happen, but I usually let everybody know on my Facebook page. So if you're not a member of the Facebook page, go join. I let everybody know whether I'm going to be here or not. Okay. But usually I'm here. I wasn't here last week because I had prior commitment going on, but usually I'm here every Wednesday evening, and we bring something new just about each week. So again, sometimes people send me questions, and we'll talk about the questions, and we'll go over the questions and the thing. I don't always go this long. 7, 8, 9, 3, over 3 hours. I don't always do 3 hours, just so you know. And 3 hours is a lot for somebody to stay focused, okay? So again, if you got something out of it and you felt like you learned something, you enjoyed it, consider donating, help us out. If you get any of our courses, we thank you. And again, you can always reach out to me. And you can always go to the website and donate on our masterthenec.com, just like the URL that you see right here. You also can find out about our courses if you want as well. You can ask me any question you want, send them to me, come each week, and enjoy it. And hopefully you get something out of it. And again, I don't claim to always be a know-it-all. I try to make things easy to understand. Sometimes I don't get that. Sometimes I get convoluted in it, but I do my best and try to break it down. You know, it's different when I teach exam prep versus when I teach classes to electricians that have years of experience. My classes are totally different. I expect them to know a certain level of knowledge. Okay. And so again, we're going to go right into code. We're going to go right into explanations. When I do exam prep, and it's not just y'all, when I teach exam prep, I try to think of ways to break it down. And sometimes I can get lost in a breakdown loop, but I try to do my best, and that's all I can do. Okay. All right. Well, if there's, you know, again, check out our YouTube channel, tons of videos. And look, what you see on the screen is not all of our videos. You need to go to, let me show people that are watching real quick. Let me show you how this, because I get a lot of people ask this question. When you go to our YouTube channel, kind of interesting. When you go to the YouTube channel, and you go to my channel, let me just go to my channel. Here's what the channel looks like. Of course, this is a show that's live right now. You have all these playlists, right? But you also can search through them. You can click on videos. And notice that it only shows videos to a certain point. I mean, look at all these videos, guys. Okay. Check out this one here, Electrician Live, talking about EMT. Look, there's a lot of other exam prep videos that you can watch on here. We do the same thing we did tonight. There's calculations. I do one on math. But, you know, it goes back for, you know, this is just 8 months, 10 months. But what I wanted to show you is that you sort right here, most popular. See how this says date added the oldest? Right now it's on the newest. So these are always the newest. But check this out. If I click on the oldest, look at these. 5 years ago, 2014 code, 2017 code, 4 years ago, 5-part series on pools and spas. Here's one of me inspecting an electrical panel. Look, there's some old ones in here, okay, that are very beneficial. Here's me doing a gun review. Forget that one. Look at this one. Here's my D rating demystified. That was 2 years ago. Here's understanding parallel and series calculations. Okay. Here's one. Here's the motors video. Here's the range simplified. There's just so many here. And look, these are quite. Check out this series. Everything you wanted to know about transformers. Part 1, Part 2, Part 3, Part 4, Part 5, Part 6. They're all there. One of the videos you should be watching is this one. How to identify the root of an electrical exam question. That was done over a year ago. Now, these are podcasts. These are for listening. Look, I have a podcast on box fill, 2 parts. And as you scroll down, you'll see that I have a bunch of stuff in here that you can listen to. Let's see here. Let's see some of the newer stuff. Look at here. Sizing grounding electrical conductors, sizing equipment grounding conductors, service bonding basics, supply side bonding jumper calculations, more motor calculations. Here you go. Pull box sizing right here. Introduction to conductor insulation. Introduction to our Electricity 101 course. There is tons of videos that are here that you might never see unless you actually went in and clicked on the sort. Now, if I go back to the new, then that's going to be the most recent one. This is the one that you're watching right now. Okay? But there's a lot of videos that are still on here. Okay? So, again, I just want to make sure you know that there's all kinds of videos that are available that are here. Okay? So, Don't just think that there's just a few there when you go to the main, you go there. Go searching through it. Now, I've tried to put them all in playlists, so it's easier to find. Calculations, just go to that playlist and everything like that, okay? So, I'm tired. I'm ready to go. It's been a long day. So, everybody, I want to thank you for taking the time and joining me tonight. Take care. God bless. And again, I'm here to help you any way I can. So, again, reach out to me if you need me, and I'll do my best to try to help you anytime. Thank you again to everybody that's donated. And if you know you donated, then be sure to make sure that you send me your email address, not your email address, your physical address, so I can get them out to you. And, let me know, what do you want? You want the light or you want the screwdriver, okay? If you're selected, okay? All right? But I need everybody's address so I can tell you who won, okay? All right. Till next time, folks, stay safe. God bless.